Welcome to the first of 3 videos delving into what typically makes up a mobile hybrid app. But first, let's define at a high level what a mobile hybrid app is in the first place. A mobile hybrid app is an app designed to work on a range of mobile devices, including tablets and phones. These devices come in a wide variety of form factors, and hybrid apps need to adjust their appearance depending on the device upon which they are installed. As the name implies, a mobile hybrid app is a mix of technologies. A portion of the app uses native technologies such as Java, C, or Swift, while another portion uses web technologies including JavaScript, cascading style sheets, and HTML. Finally, most mobile hybrid apps work across more than one platform, and this is often the common reason for building a mobile hybrid app in the first place. Over the course of the videos in this section, we're going to delve further into these topics in more detail, as it is critical to understand the various parts that exist in a typical mobile hybrid app. We'll cover how mobile hybrid apps leverage web technologies, how they interface with native features on the device, and how they can be cross-platform even while using a single codebase. In this video, we'll cover how a mobile hybrid app leverages web technologies to provide a rich end-user experience. We'll first take a look at the system web view used by both Android and iOS. Then we'll take a high-level look at HTML, CSS, and JavaScript, and how these can generate a dynamic end-user experience. First, let's talk about the system web view. As you might imagine, in order for any mobile hybrid app to use web technologies, it's going to be using some sort of web rendering technology. Although it's important to understand that a mobile hybrid app is not a web browser, let's take a quick look at a typical mobile web browser just to see what a web view really entails. Right now, you can see Pack Publishing's website loaded into mobile Safari on my iPhone. At the top of the screen is mobile Safari's Chrome, or the user interface. This is what the browser itself presents to the end user, and websites have little to no control over it. In a mobile hybrid app, we don't have any of this. A mobile hybrid app is responsible for providing its entire user interface. The middle portion of the web browser, in which you can see the content scrolling, represents the web view. This is where HTML is rendered, and it is the portion that mobile hybrid apps use to leverage web technologies. Let's take a quick look at a web app running within the confines of mobile Safari. In this example, you can see both the Chrome of the app and mobile Safari's Chrome. When running on its own, this app wouldn't have any of the Chrome outside of the highlighted area. It is important to understand that mobile hybrid apps don't inherit the browser's entire functionality. This means that there are some activities which would otherwise render in the browser's Chrome which a mobile hybrid app has to handle on its own. For example, the tab view on mobile Safari is something provided by the browser. Although it's possible to achieve something similar in a mobile app, it's up to the developer to write the code and animations to create the same interface. A mobile hybrid app, then, supports the use of web technologies by using a web view. Let's quickly discuss the technologies in play. First, HTML, short for Hypertext Markup Language. HTML applies structure to a hybrid app's content, but must also provide the structure for the app's user interface. HTML5 is the most recent standard, and is what we'll be using in this and other courses. JavaScript is a programming language that can be used to modify the app's user interface and to create a dynamic app. It can be used to download content from a remote server, calculate complex mathematical equations, or even play a game of chess. The most recent standard of JavaScript is ECMAScript 2016. And that's what we'll be using in this and other courses. CSS, or cascading style sheets, is used to describe the appearance of the app's user interface and the app's content. The most recent standard is CSS 3, and we'll be using that in this and other courses. Together, HTML, JavaScript, and CSS combine to create the result that you see on screen. This is a mobile hybrid app. As you can see, it doesn't have any of the mobile browser's Chrome. Instead, it fills the entire screen. This course will not be a primer on HTML, JavaScript, or CSS. If these technologies are completely new to you, You should become familiar with each before proceeding with this and other PhoneGap courses. There are lots of great videos online at Pact Publishing's website that should get you started. That said, you don't need to be an expert in these technologies in order to follow this and other PhoneGap courses. Whether you already have a lot of experience in these technologies, or if you're only a beginner, you should be able to progress through these videos. In this video, we discussed how a mobile hybrid app leverages web technologies in order to render the user interface and display content to an end user. In the next video, we'll cover another facet of mobile hybrid apps, how they can interface with native device features. I'll see you then. In the previous video, we discussed how mobile hybrid apps leverage the system's web view in order to render HTML, CSS, and JavaScript. These are the building blocks of our mobile hybrid apps. In this video, we'll discuss how mobile hybrid apps can interface with native features provided by the device. In our context, a native feature refers to a device function, such as interfacing with user contacts or interacting with device sensors and storage. In this video, we're going to take a look at the two mechanisms through which access to native device features are provided. First, some features are actually provided by the system web view, and these would be available even within the context of most mobile browsers. However, access to most other native features are provided by a plugin system. These plugins can provide an interface to the web portion of a hybrid app for just about every native feature provided by the device. So just what kind of features fall into which category? On the left, you can see a sampling of the features that are provided by the web view. For example, if you needed to locate the user's device using GPS, you could accomplish this using an API provided by the web view. This same API exists within most modern web browsers, including those that exist on desktop machines. On the right, you can see a sample of the features that can be provided by plugins. Whereas a web view does provide some degree of storage, it is limited in both lifetime and quantity. Using a plugin to access the device's persistent storage, a hybrid app can use as much space as is available and persist that data for as long as the user allows. Some features have no analog whatsoever in the web view context. For example, accessing the user's contacts simply isn't possible in the web view without the aid of a plugin. Other features may be considered standards that mobile browsers should implement, but that not all do so correctly, if at all. In this case, plugins may also be provided to ensure that a feature that should be provided by a web view actually works on all targeted devices. In this diagram, the web view on the left contains the entirety of a hybrid app's HTML, CSS, and JavaScript. On the right are listed just some of the native device features such an app might want to access. Plugins allow access to native device features not provided by the web view by using what's called the native bridge. This is located in the middle between both containers in the diagram. This is a small piece of code that understands how to communicate between the device and the web view. Typically, the native bridge is also of a hybrid nature. Part of it is JavaScript and interfaces with the mobile app's own JavaScript, and the other part is native code, such as Java or Objective-C, and interfaces with the native code provided by a plugin. There are a lot of plugins available for PhoneGap. As of last count, nearly 1,400. There are plugins that allow a hybrid app to access just about every feature of mobile devices. These are all available at the PhoneGap and Cordova plugin repository. Let's take a look at what it looks like and get a quick feel for what's possible. This is the plugin repository used by Cordova and PhoneGap. You might be wondering just exactly what Cordova is when this is a PhoneGap course, but we'll cover that in the next section. For now, think of them as siblings. The plugins themselves are hosted on NPM, the Node Package Manager repository. The Cordova plugin repository filters NPM's content and lists the plugins that a PhoneGap app can use. As I scroll down, you can see lots of plugins. Each plugin has support for many different platforms, indicated by the icons under the plugin name. The plugin's last version number, last update, and download statistics are also displayed. So far, the first plugins you've seen on this list are core plugins. These are plugins supported by the same developers that support PhoneGap. However, There are a lot of third-party plugins available as well, and these interface with lots of third-party services as well as the native features provided by the mobile devices. If you have an idea of a plugin that you need, you can search for a keyword. As you can see, the search results have now been limited to those plugins that work with user contacts. Let's choose one. When you click one, you'll be able to read the documentation that accompanies the plugin. Be sure to read this documentation closely, as it will indicate how you can install the plugin in your app, how the plugin works, and if there are any quirks or issues that you need to be aware of. In this video, we discussed what native features are and how some are provided by the web view itself. For those that aren't, these features can be accessed by the native bridge, which provides the basis for extensibility via thousands of plugins. In the next video, we'll cover how a mobile hybrid app can target many mobile platforms while utilizing a single codebase. See you then! Welcome! In this video, we're going to discuss how a mobile hybrid app can be cross-platform in nature. Often, this is a huge selling point when determining if one wishes to develop a native or hybrid app in the first place. We are going to take a look at the following topics: web technologies and the fact that they are inherently cross-platform, how a single codebase can be better than the alternative, and the platforms that this course will support. HTML is not a recent development. It was initially released in 1993. Of course, the version released then was not nearly as sophisticated as the current version, HTML5, but it brought about a revolution in the way we viewed connected computing and the sharing of content across platforms. When HTML was initially released, there was only one text-based browser that could render it. But it didn't take long until a graphical browser appeared on the scene, and the various browsers available exploded over the years. As you can see, nearly every browser has functioned on many different platforms. As a whole then, HTML was always cross-platform. While there were differences in how each browser rendered content, the content itself was the same. Thankfully, HTML has progressed quite a bit since those early days, and all modern browsers support HTML5 to some degree. Because not every modern browser supports all facets of HTML5, one still has to take that into account. But this is the case when building web apps and even native apps, especially when maintaining backwards compatibility with older operating systems. Modern web browsers use one of a few rendering engines. Of note is that the two platforms with the most market share also share a similar rendering engine. Although they are not identical with regard to feature set, this can greatly simplify development for these two platforms. If one seeks to develop for platforms using another engine, some code may need to be adjusted, but generally frameworks and libraries that are used as the basis of a mobile hybrid app will take care of the differences. The worry of having to build and maintain multiple code bases when releasing a new app is often the reason a mobile hybrid app is considered in the first place, and for good reason. Each platform supports different programming languages and SDK frameworks. Each platform often has very different developer tools as well. You can see a very simple example of the differences in code just between iOS and Android at the bottom of this screen. If one's app needs to target additional platforms, the number of code bases increases. Because mobile hybrid apps are a mix of native and web technologies, they are, by necessity, a mix here as well. The native portion of a mobile hybrid app is indeed specific to each targeted platform. Unless you're actively writing extensions for native functionality, though, you generally won't have to worry about this much. The web portion of the hybrid app, however, can be the same code running on each targeted platform. This doesn't mean, however, that your app must look and feel the same on all devices. In fact, that's actively discouraged by all the mobile platforms. As such, you can detect the platform if necessary, change the user interface to feel more at home on the targeted platform, and you can verify if a feature is available on a specific device or platform before trying to use it. Because each platform and supported devices have differences, your code will almost certainly need to have workarounds for various issues and glitches. Certain features may only make sense on certain platforms and device classes as well. Instead of building separate code bases for all of this, one can handle each case with conditional logic. I'm not going to go over what each of these examples on the screen is doing, The important part to recognize is that this code is running on every supported device and platform. The code itself makes the determination to enable or disable certain features or to change the look and feel of the app based on the device it finds itself running on. This isn't to say that you might not have files that are specific to a given platform. For example, in my apps, I may have style sheets that only get loaded if one is running on an Android device. Or I may have a feature implemented in JavaScript that applies only to Android. Taken as a whole, however, it is the app and the build process that determines which code to execute and which style sheets to use. All of these differences exist in a single project, hence a single code base. Unfortunately, it isn't always feasible to support every available mobile platform in the world today. The most common platforms are iOS and Android, and that's what we'll support in this and other PhoneGap courses. Targeting other platforms isn't much more difficult, but these are the two platforms that we will be testing on. Of course, we won't be supporting really old versions of the operating systems on each platform either. For iOS, we'll assume a minimum version of iOS 8. This captures a huge majority of the market and allows us to include features that older operating systems simply didn't support. For Android, we'll support Android 4.4 or better. This doesn't capture the same market as iOS, but it's still pretty sizable. In this section, we discussed how mobile hybrid apps leverage web technologies to generate a rich user experience, how the web technologies can interface with the native features of the device, and also the cross-platform nature of mobile hybrid apps. So far, we've been pretty generic about mobile hybrid apps. There happen to be a lot of ways to build them. In the next section, however, we're going to get specific about what PhoneGap is and some of the history behind it. See you then! This is PhoneGap 101. This course is about creating mobile hybrid applications using PhoneGap. My name is Carrie Schatz. I've been working with PhoneGap for several years, and I've written several books about it and used it to build apps for my clients. In this first video, I'm going to give you a quick course overview to whet your appetite, so to speak. So, what is this course about? It's about creating hybrid mobile applications using Adobe PhoneGap or Apache Cordova. These two tools are pretty much identical. Adobe PhoneGap happens to be a distribution of Apache Cordova with some value adds. Adobe PhoneGap and Apache Cordova also allow you to reuse your knowledge of HTML, CSS, and JavaScript, but apply that in a mobile context. Throughout this course, we're going to be creating a working productivity app named Filer. In this course, we're going to look at the following topics. First, we're going to introduce you to PhoneGap and what a hybrid app is, as well as the various faces of PhoneGap. Then, we will walk you through installing the required software development kits and other prerequisites for using PhoneGap. These include Node, Xcode, Android Studio, and the PhoneGap CLI. We'll also make sure that your install is correct. In the last sections of this course, we'll cover how to create our first mobile app, Filer. We'll cover what a framework is, and we'll cover how we designed Filer, created our models, and how we wrote the code to list notes and add and edit notes. And then finally, we'll wrap it all up in a nice, neat package. By the end of this course, you should be able to properly configure a PhoneGap CLI environment. You should also be able to build a simple productivity app using PhoneGap. And you should be able to run that app on your devices and simulators. This course, we're going to be creating a simple note-taking app called Filer. Its goals are simple. It lets the user create notes, reorder them, and edit them. And it stores those notes persistently. This is what Filer looks like when running on an iOS device. To the left is the list of notes. In the middle is a note with various pieces, and a note can have multiple pieces. And on the right is the user editing one of those pieces. The Android version of this app looks very similar, except that it uses material design. Before we go any further, I want to point out some useful tools. Now, most of what we'll do with PhoneGap is command line centric, and we'll also be using a text editor. Now, a text editor is sufficient, but I prefer an integrated development environment that understands JavaScript. I happen to use Visual Studio Code. The link is on screen. But there are a lot of other great editors out there that can be configured to understand JavaScript, including Atom, Brackets, WebStorm, NetBeans, and many more. You should take a moment to discover which one works best for you, because you're going to be using it a lot. Next, I want to talk about the code package for this course. The code package is available at the repository on screen, and you can download it with a zip file and decompress it. Or if you have Git installed, you can clone the repository. Be sure to review the prerequisites in the README file, because there's some important information there. You really need to download this. There's too much code to actually guide you through every keystroke. So, you'll want to be working from the project structure that we've already created for you. So I hope at this point you're excited to get started. So, if you're ready, and you've downloaded the code repository, double check the requirements. Let's do this thing, and we'll see you at the end of our journey. In the previous section, What is a Hybrid App?, we stayed pretty generic. In this section, however, we're going to delve into the specifics of what PhoneGap is and how it helps us accomplish our goal of a cross-platform mobile hybrid app. In this section, we're going to discuss the history of PhoneGap, when it got started, the various transitions the project has gone through, etc., the differences between PhoneGap and Cordova, and we'll also be more specific as to how PhoneGap works. In this video, we're going to delve into the history of PhoneGap. Although you might be itching to write some code, it's important to understand the genesis of PhoneGap and how it arrived at the current state. This is because there is a lot of information out on the internet that, depending on which state of PhoneGap's evolution it was written in, may not be terribly useful and even flat out wrong. To help you sift through that advice, it is important to know when and how PhoneGap came to be what it is today. In this video, we're going to cover the genesis of PhoneGap, how and when it got its start. We'll also cover the evolution of PhoneGap, including the purchase of the founding company by Adobe and subsequent donation to Apache as open source, all the way to the modern PhoneGap era. The first iPhone was released in the middle of 2007 and changed the mobile phone market forever. Although it seems odd now, the original iPhone did not have an app store. Instead, the iPhone came with a very capable web browser named Mobile Safari, and the original vision was that developers would create web apps for users to use via bookmarks. These apps were subject to Mobile Safari's limitations, and developers quickly clamored for direct access to the device's hardware. This came in iOS version 2 not quite a year later in 2008. When the iOS SDK software development kit was released, however, it required learning an entirely new language, Objective-C. Those who had developed web apps, however, wanted to be able to reuse their web development skills while also being deployed via the fledgling App Store. PhoneGap was originally developed in 2009 by a company called Nitobi Software as a means to do just that. Technically, the goal was actually to eliminate itself as a product. The hope was that mobile browsers and operating systems would come to support the W3C widget specification, and so eliminate the need for a native wrapper like PhoneGap. In short, the initial versions were considered to be a polyfill for the W3C specification. In practice, however, mobile browsers and operating systems never took up the W3C specification, and the environment surrounding PhoneGap has exploded with thousands of third-party plugins that would never be fully supported by every browser and platform anyway. So for the foreseeable future then, PhoneGap will be needed as a cross-platform bridge from web technologies to features native to supported devices. The first versions of PhoneGap were very different than today's versions. Obviously, differences in functionality exist, but more importantly, the project structure was very different. Up through the last 1.x version, PhoneGap was available as a project template for supported platform IDEs, integrated development environments. In order to build an iOS version of your app, you would download Xcode, create a new app based on a PhoneGap template, and then copy in all your web code. To build an Android version, you'd do something similar, but using Eclipse at the time. If you were targeting one and only one platform, this was easy. The only prerequisites were the same prerequisites for any other native development, and you could use the plethora of available documentation available for these IDEs to get a PhoneGap app configured properly. But for cross-platform development, this was a nightmare. There was no good way to keep these separate apps in sync. If one made changes to, say, the iOS app's webcode, it would have to be duplicated in all the other projects, and vice versa. It was possible to keep track of this with hacks, either by copying code manually or using symbolic links, but there had to be a better way. PhoneGap was noticed by Adobe, and Adobe purchased PhoneGap in 2011. As part of the arrangement, Adobe would retain the name, but the code at that point was donated to the Apache Software Foundation. Originally, this new product was called Apache Callback, but this was considered to be too generic, and Apache Cordova was chosen as the new name. After the purchase, Adobe PhoneGap was based on Apache Cordova with additional value adds created by Adobe. This is a practice that continues to this very day, and this is why you'll often hear Cordova and PhoneGap used almost interchangeably. However, as you'll discover in the next section, they aren't completely synonymous, so it's important to be aware of the differences. After PhoneGap was acquired, work began in earnest to transform the workflow needed to manage a PhoneGap project. The Command Line Interface, or CLI, was introduced, and although it was initially limited in scope, it quickly grew to become the preferred method for managing PhoneGap apps, even though it introduced additional dependencies like Node.js. This new workflow was a bit different than the old workflow, however. Instead of creating a project within an IDE based on a template, the project was created from the command line. An authoritative source was also introduced for the web code. This is called the project's or root web directory, or www directory. Each added platform to the project had its own web directory as well, but the CLI kept these in sync for the developer. It was still possible to open the platform-specific code in an IDE, but that was largely reserved for testing and debugging, or for working with native code. Modern-day PhoneGap is quite mature, although progress continues to move rapidly. This occurs in both the underlying Cordova project and the resulting PhoneGap distribution's value adds. In the modern environment, however, it is possible to pin these dependencies to a specific version, and so it is easy to share a working environment with a team and only upgrade on an as-needed basis. In general, one typically uses a single version throughout the entire development cycle unless there's a bug that is addressed in a later version, or there is a security issue that can only be fixed by upgrading. It should also be noted that PhoneGap isn't the only tool based on Cordova. There are other tools such as Ionic, Monica, Taco, Telerik, and the Intel XDK that also use Cordova. This means that often your skills with Cordova and PhoneGap can be easily transitioned to other similar environments with different value adds, should those value adds become important to you. This slide presents a very basic timeline for the progress of PhoneGap from the first days to the last major release version. Whenever you search for information online and version numbers aren't explicitly identified, you should be able to use this to figure out roughly which version of PhoneGap for which the information was intended. In this video, we took a journey through PhoneGap's short but storied history, as well as its relationship with the Apache Cordova project. In the next video, we're going to highlight the similarities and differences between Cordova and PhoneGap. As you've already seen in the prior video, Adobe PhoneGap is actually a distribution of the underlying Adobe Cordova project. Usually these terms are used synonymously, but in this video we're going to cover some cases where that isn't true. In this video we're not focused on history. We're only worried about modern PhoneGap and Cordova. We'll cover the similarities and differences between Cordova and PhoneGap, illustrate this with a quick look at the two CLIs, and we'll also mention some of the other distributions based on Cordova in case you want to investigate those distributions in the future. The skills you learn in this course will serve you well with those distributions. There's a pretty good reason PhoneGap and Cordova are often considered synonyms. They are very much alike. Both are open source and their communities are very nearly the same. Both CLIs share the same or similar commands, so you usually can adapt from one CLI to the other with little to no difficulty. The project structure is nearly identical in most cases, and so you can actually use both CLIs with the same project files. Both Cordova and PhoneGap can use the same exact plugins and platforms, which means that aside from the value adds, the workflow is interchangeable, and your code will be the same regardless of which tool you use. All that said, PhoneGap isn't strictly a synonym of Cordova. They aren't identical projects. PhoneGap has additional value adds, including additional faces that can assist with development. There are 4 faces currently: the PhoneGap CLI, which is based on the Cordova CLI, the PhoneGap Desktop. This is a graphical user interface app that makes it quick to start with PhoneGap. PhoneGap Developer App. This is a way to run your apps on mobile devices without an intervening build step. This is most useful for rapid iteration. And PhoneGap Build. This is a build service in the cloud. We'll discuss these faces in more detail in the next section. For now, the most obvious differences are that the PhoneGap CLI supports additional commands and integrates with both PhoneGap Build and the PhoneGap Developer app. Because it's a distribution of Cordova, it tends to lag behind the Cordova CLI slightly, but this is almost never an issue in practice. Let's take a look at some examples of the similarities and differences between the Cordova and PhoneGap CLIs. I've got my terminal up, and Cordova and PhoneGap are already installed. We'll discuss installation in an upcoming section, so don't worry about that now. On the left, I'm going to display Cordova's help, and on the right, I've displayed PhoneGap's help. You should already be able to see the similarities and the differences. Let me highlight a few, though. The create command is the same, for example, as are the platform, plugin, and prepare commands. The telemetry and analytics commands aren't identical, but they serve similar functions. But push, remote, and Cordova on the right are definitely not included in the Cordova CLI. Next, I'm going to create a project using both CLIs. Note that the commands are the same, except for the CLI name. The output isn't quite the same. The PhoneGap CLI tends to be a little more verbose. Let's take a look at the structures created by the CLIs. As you can see, the Cordova CLI created a pretty basic project. The PhoneGap CLI, on the other hand, created a much larger project. Don't be worried by this, however. This is because the two CLIs use 2 different templates. The similarities are more obvious if we look at the top-level structure. Note that the config XML, www, platforms, and other directories are named the same and in the same place. In short, the reason these 2 projects look different is because they are based on separate templates. In our apps, we'll build off the same template, so the structures would actually be identical. It's important to remember that your code is the same, regardless of which tool you're using. Most of the times, your project structure is also the same, although some PhoneGap faces may require a different structure. Interaction with the tooling is the most obvious difference between Cordova and PhoneGap, and it is up to you or your team to determine which tooling works best for them. Both function well, and in nearly every case, both Cordova and PhoneGap will work the same in this and other courses. We'll annotate where that doesn't hold true. We mentioned it briefly in the previous video, but there are many other distributions of Cordova that you can pursue. The tools on this slide are all based around the Cordova CLI in one way or another. Some are opinionated in that they'll suggest a framework, while others are just helper tools to make developing apps even easier. Feel free to explore these. The skills you learn in this course and other courses will also serve you well with these tools. In this video, we covered how PhoneGap and Cordova are alike, and how they are most obviously different. We also mentioned additional distributions of Cordova that you might want to investigate later. In the next video, we're going to delve into the inner workings of PhoneGap and discover how it integrates web technologies with native technologies. In the final video of this section, we're going to take a closer look at just how PhoneGap works. We'll discuss just how web technologies are wrapped by PhoneGap, what the config XML file is, how the native bridge works in more detail, and a little bit about deployment of your app to devices. As we've mentioned in previous videos, PhoneGap apps are a combination of native and web technologies. The CLI performs the tasks necessary to manage both of these sides of our app. When a PhoneGap app is initially created, the project has only 2 things: a configuration file named config.xml and a www or web directory that contains sample code copied from a template delivered with PhoneGap. The PhoneGap CLI tends to create more directories than does the Cordova CLI, but these other directories are typically empty. In this state, there's no native code present. As it stands now, the project can't do much, since it doesn't know how to start up on an iOS or Android device. When a platform is added using the CLI, a native project for that platform is created in the Cordova project. The native project has the ability to bootstrap our app on the newly added platform, and it can read the various configuration settings defined in config XML. It can also create a system web view and load our project's index.html file. Note also that along with the native code, that a copy of the project's web directory has been added to the native project. The CLI will manage this for us and keep it synchronized with any changes that occur in the root web directory. It's important, then, to ensure that one only edits the top-level web directory. Changes in the lower-level web directories can be overwritten whenever the CLI pleases. The configuration file is very important. At its most simple, it specifies the app's name, unique ID, version number, and some metadata. Typically, additional settings are also specified. Some of the settings are platform-specific, while others apply to all supported platforms. Plugins and platforms, including version numbers, can also be stored here, making it easy to keep track of dependencies and their associated version numbers. When you create a project, you will typically get a pretty simple config XML file, so rarely do you have to create one completely from scratch. Instead, you can just edit the file created when the project was created. We've already discussed the native bridge in this and the prior section, but now it's time to see it in more detail, namely to see some code. After the app is bootstrapped by the native code, the web view is initialized. One of the first tasks is to start the bridge and initialize any other plugins that the project may be using. Because this isn't available immediately when the web view is created, it's important to wait for a special event, device ready. You may be familiar with waiting for the web document to finish loading, and this is somewhat similar. Instead of waiting for the document to be fully loaded, we are actually waiting for the bridge and plugins to become available. Because so many things rely on the bridge, including all the plugins that are used, it's safest to wait until it is ready before actually starting the web portion of our app. While you can technically do some things in advance, it's just easiest to wait. Once the bridge is active, it communicates any intent to use native features to the native code. It also communicates responses from plugins back to our web code. Due to the nature of the bridge and JavaScript, this is done asynchronously, which means every call over the bridge that expects a response will use callbacks, as you can see in the code on the right. Let's take a moment and look at this a little bit. Cordova exec is a method that passes a request to some plugin over the bridge. It takes at least 4 parameters. The success callback is a function that is called when the request completes successfully. No errors occurred during processing. Typically, additional data is usually passed back. The failure callback is an error handling function called when the request failed in some way. The reason for failure will always be passed back in the form of an error code and a message, and sometimes additional data will be passed back here as well. The next 2 parameters indicate which plugin we're trying to talk to and which command the plugin should execute. Some plugins can accept additional options and parameters, and these always come at the end. Typically, though, we don't write code using Cordova exec. Instead, the plugin typically provides a JavaScript interface that we can use instead. When it does so, the code looks a little bit more like this. The success-failure callbacks are still there, but the code is a little easier to read. Once the plugin has completed the request, one of the functions at the bottom of the code will be called. If everything worked correctly, our success callback will be called. If something failed, the bottom function, or failure callback, will be called and will almost always be supplied the reason for failure. It's important to remember just about every plugin in the PhoneGap and Cordova ecosystem works along these lines. Here's a diagram that might make the bridge a bit easier to understand. Time starts at the top and progresses downward. On the left is code we've written that's calling a specific plugin. In the middle is the bridge, and this is code provided by PhoneGap. On the right is the plugin itself, and this is also native code. When we use the plugin's JavaScript interface, the plugin's interface makes the call to Cordova exec for us. Cordova exec then places that request into a queue that is used by the bridge. Just so you know, a queue is used so that if multiple requests were to come in, they can be processed in order. The bridge picks up that request the next time it looks at the queue. It often does some translating from JavaScript types to native types, and then passes the request on to the plugin. The plugin then executes the request. It then returns a success or failure response to the bridge, both of which may include more data and information. The bridge receives the response, performs any type conversions necessary, and then triggers the success or failure callbacks in our code. On the JavaScript side, our code finally gets triggered with the response from the plugin. Because the plugin and bridge may have had to do some processing, it might actually be quite some time since we initiated this whole process. Does that mean that the JavaScript code itself stops executing? No. The web view is typically still active and executing code during this time. This means that we can't just call a plugin and then expect our code to stop and wait for the response. Our code will still go on executing. And this is why callbacks are used. Our code that can then be notified when the plugin has finished its work. In order to test or deploy our code to a device, PhoneGap provides a build step. This step packages the web content and compiles the native code, including the bootstrap and any plugins. The result is a package that the target platform knows how to install and execute. This step can also sign the resulting package, which is important for production deployment and necessary for deployment to app stores. We're going to cover this in a later course. Once the app is built, it can be deployed to an emulator or a simulator or to a physical device. The native IDEs for each platform, Xcode or Android Studio, provide tools that make this simple. But since the PhoneGap CLI is command line driven, it would be tedious to have to open up Xcode or Android Studio each time we wanted to run our code. So the CLI provides a couple of commands that do this for us. There's two such commands, emulate and run. The first only tries to deploy the app on an emulator or simulator. These aren't typically used for final acceptance testing, but they are very handy to have on hand for testing against various operating system versions and such in a hurry. Run is for deploying to physical devices. Technically, the result is the same in both cases. Our app is running, but there's a reason for the distinction. An emulator may run on a different CPU architecture, and so the code may need to be compiled differently than when targeting a physical device. Of note is that the CLI doesn't worry about providing any debugging functionality. There are some great tools for doing mobile debugging, which didn't used to be the case, but we won't worry about those in this course. We'll delve into those in a later course instead. In this section, we covered the history of PhoneGap, some of the differences between PhoneGap and Cordova, and in this video we delved into the details of how PhoneGap works, including how web code is wrapped into a native bundle, how the native bridge really works, and how the CLI can deploy our code to emulators and devices alike. In the next section, we're going to explore the various faces of PhoneGap. There are several faces available, and it's important to be aware of how they can help you in mobile hybrid app development. See you then! Welcome to Section 3, Exploring the Face of PhoneGap. In this section, we're going to explore the PhoneGap command line interface in more detail, and we'll also discuss the PhoneGap build service and the PhoneGap desktop developer app, and why you might want to investigate these services. In this first video of Section 3, we're going to get familiar with the PhoneGap CLI. Specifically, we're going to go over the pros and cons, how to get help from the command line interface, and we'll wrap up with talking about some of the commands. On this slide are listed several pros and cons for the PhoneGap CLI. First, the CLI is the most flexible of all the faces. Building is entirely under your control. You can fit the CLI into just about any workflow, whether you like to use a text editor, a complex IDE, or some other process. The CLI can be used with all the other PhoneGap faces, which we'll get to later in this section. Lots of IDEs, integrated development environments, and utilities integrate with the CLI as well. Visual Studio Code is one of my favorites and sports deep integration with the CLI. Other editors like Atom, Brackets, and WebStorm can also interface with the CLI. Just about any build tool can use the CLI as well, which is useful from an automation perspective. That's not to say that there aren't downsides. The CLI is the most difficult to get properly configured on your development machine. It requires several prerequisites. It requires that the SDKs, software development kits for each platform you're targeting, be installed and properly configured on the system. This has some consequences if you're targeting iOS or Windows. The associated SDKs only run on their respective desktop operating systems. If you want to target iOS, you need macOS. If you want to target Windows, you'll need Windows. Targeting Android, however, is possible from Linux, macOS, and Windows. It can be sometimes difficult to diagnose problems, especially for forum volunteers or support, because the errors you may encounter will be dependent upon your system configuration. Although it's not exactly a con, in my opinion, the PhoneGap CLI will also expect that you're familiar with a command line, whether that be a terminal on a Linux Mac system or the command prompt on Windows. We're not going to cover installing the PhoneGap CLI just yet. As mentioned, it takes a bit of work to get it properly configured. We'll cover this for macOS, Linux, and Windows in the next section. Once it is installed, however, the CLI offers a pretty good internal help system. It's very easy to get help. PhoneGap help is all you need, and you'll get a screen like this. Should you need more information about a command, you can just type PhoneGap help and then the name of the command, and the CLI will give you options, examples, and other useful information. On this screen, the help is showing you information about the create command. As we've mentioned several times already, the PhoneGap CLI is based on the Cordova CLI. The PhoneGap CLI provides a mechanism for sending Cordova commands directly if you choose. Just type PhoneGap Cordova and then the Cordova command. It's not uncommon for both CLIs to be installed on the same system. They are interchangeable for local builds. It's always important to know the version of the tool you're using, especially when seeking support. The PhoneGap CLI makes that easy. PhoneGap version will show you the currently installed version. Normally, the CLI will also inform you if there's an update, but if you want to check yourself, you can type npm info PhoneGap version, and npm will return the most recently published version. If you want to upgrade to it, you can then do so. The CLI focuses mostly on two things: project management and deployment. Management is concerned with creating the project, adding plugins and such, and compiling and packaging the bundle. The create command is used to create a PhoneGap project, as you've already seen in section 2. It will always be your first step when creating a new PhoneGap project. The platform and plugin commands are used to manage platforms and plugins used in your project. Usually these are executed soon after creating your project and then aren't needed again, at least within a particular revision, unless an upgrade is needed to address a security issue or a bug in a platform or plugin. The prepare, compile, and build commands are used to compile the native bits and package the web portions into a bundle that can be deployed to a device. Build is actually an alias for prepare, then compile. Prepare does all the work necessary to copy your project's web files into the targeted platform's web files, and also configures the target platform's native portion appropriately. Compile is self-explanatory. It invokes the native SDK's compiler to compile all the native bits, and then uses it to bundle both the native and web technologies together. Info is purely informational. You can use it to show information about your PhoneGap project. If you ever need to obtain support or ask a question on the support forums, this is information that will be useful. Deployment in this context is simply getting the compiled app bundle onto a physical device, not about deploying to an app store. Run is usually used to target physical devices, although it can be used to target third-party Android emulators as well. Emulate targets emulators and simulators. For iOS, this would launch the iOS simulator. For Android, this would launch the Android emulator instead. Serve is an integration point for the PhoneGap developer app, and we'll cover this later in this section. Quickly though, it's a way to test on physical devices without a build step. The PhoneGap CLI has another integration point, this time for PhoneGap Build. Using the CLI, you can upload your app to the PhoneGap Build service and compile it in the cloud. You'll learn more about this in the next video. Before we close this video out, there's a few important things you need to know. First, the CLI is versioned separately from platforms your app is targeting. In this example, the CLI is at version 6.3, while the Android version is at 5.2.1 and iOS 4.2.0. Do note that these version numbers have nothing to do with Android or iOS's version number. These are the version numbers for the native and wrapper code necessary to support your web code. Generally, you can update the CLI without upgrading any attached platforms. Most of the work is done in the platform. The CLI is a front for platform-specific code. Also, as I mentioned earlier, each platform requires that that platform's SDK be installed if you're going to be building locally. As you can see, Android is the most cross-platform friendly target. Lastly, the CLI is what I'll be using in this course. You're welcome to use the other faces discussed in the next videos, but the CLI workflow is the most versatile option of them all, the most reproducible since you can control all the bits, and provides interfaces to all the other faces as well. In the next video, we'll address the PhoneGap build phase and cover some of the pros and cons and why you might want to add it to your tool belt. See you then! Hello and welcome to the second video in this section, and in this video we're going to take a look at the PhoneGap build phase. In this video we're going to take a look at the following things: the features of PhoneGap build, the pros and cons, and some of the caveats that go along with it. This is PhoneGap Build's website. You can find it at build.phonegap.com. Being a cloud service, this means that you're going to be uploading your apps to the cloud, and the cloud service will compile your app and let you download it. PhoneGap builds for iOS, Android, and Windows. It makes it easy to share and distribute builds with others. It supports a lot of different kinds of archives, including zip files or Git repositories, and you can also use this with the PhoneGap CLI. There's a lot to recommend PhoneGap build. The big point is that you don't need to have any specific development hardware until you need to deploy an app to the App Store for iOS. This requires a Mac, or more properly, it requires Mac OS, but the two tend to go together. Even with that caveat, there's still a lot to recommend it. You don't have to set up your own local platform SDKs, which means less maintenance on your part, and it's really easy to get started. PhoneGap Build also enables collaboration. Multiple users can access your app and build it. It also makes it easy to deploy your app for testing. There are two mechanisms: a QR code, in which case you can use an app to take a picture of the code and be sent to the download link, or you can just share the link itself. There are some things that you need to be aware of, however. For one, PhoneGap Build is remote. Now for some, necessarily a con, but it is something you need to be aware of because it means that you are susceptible to service interruptions. Builds are also run through a queue, which means during busy times your builds might complete a little more slowly. Sometimes if you run into errors, the error conditions themselves can be opaque and perhaps difficult to debug since this isn't a system you own. The log files are somewhere else. Although PhoneGap Build does generate a build log, if there's a configuration issue somewhere further down the line, you will have to wait until someone at PhoneGap Build fixes it. The project structure for PhoneGap Build also varies slightly from the CLI, and we'll show you this in a moment. It's also not compatible with every single Cordova or PhoneGap plugin that's out there. Most of them do work, and when in doubt, try. But if you do come across a plugin that says it requires hooks, that's not going to work with PhoneGap Build, at least not yet. A big pro of PhoneGap Build is that it produces App Store ready builds. On the downside, it doesn't upload these to stores for you. This means that you need a Mac to upload iOS builds to the iTunes App Store. For Android or for Windows, however, you don't need any special hardware to upload your apps. Sometimes, signing key management can be frustrating. It's easier to debug and configure your signing keys on your local machine, in my opinion. You also need to be aware of some size limitations. When building locally using the PhoneGap CLI, your app can be as big as you want it to be. However, on PhoneGap Build, you have 50 megabyte limits, 100 megabyte limits, or a gigabyte limit, depending on the plan. The latter two require a paid plan. The free plans only get 50 megabytes. For most apps and all the apps in this course and other courses, the 50 megabyte plan would be sufficient. But if your app is going to contain a lot of pictures, sound, videos, then you might need to consider getting a paid plan or building locally. Here's an example of project differences between the CLI and PhoneGap builds. On the left, you have config.xml in the project's root. You have two subdirectories, and you'll probably have a few more, but mainly res, resources, and web or www. Inside www, you have index.html, which is the starting page for your app, and any other files will tend to go into subdirectories here. On the right is a PhoneGap build project. This is a zip file and has a config.xml file in it, but interestingly enough, it has an index.html file that is a sibling of config.xml. It's in a different location compared to the project root on the Cordova CLI side. Also notice that the CSS and JavaScript directories have moved up a level, and they're siblings with the resource directory. It's key to remember when you go between these two that the paths in config.xml are relative to config.xml's location. So this can quite often change how your config.xml looks between a local build and a remote build. That's why it can be a little difficult to share the same config.xml between a local CLI build and a PhoneGap build project. In this course, we're assuming you're using the PhoneGap CLI. You're welcome to make the necessary changes to use PhoneGap build. It shouldn't be terribly difficult. In the next video, we're going to look at the PhoneGap desktop and developer app faces of PhoneGap. See you then! Welcome to this third video in this section. In this video, we're going to take a look at the desktop developer app face of PhoneGap. In this video, we're going to take a look specifically at the PhoneGap desktop app, the PhoneGap developer app, and the pros and cons of using both. The PhoneGap desktop app runs on your desktop. It's easy to install and has no prerequisites. It runs on Windows, Mac, and Linux. It has a graphical user interface, so it's easy to get started with and create projects with it. It's also easy to run projects and stop projects and things like that. It makes it easy to manage multiple projects. Although in this screenshot there's only one, if you had more than one it would show up in this list. It's also easy to serve an app to a browser or to the PhoneGap developer app. The PhoneGap desktop app isn't intended as of yet to be a complete replacement for the CLI. It doesn't support everything the CLI does, but if you're just getting your feet wet with PhoneGap, it's a great start. The PhoneGap developer app, however, installs on mobile devices, iOS, Android, and Windows. It connects to PhoneGap CLI Serve or the PhoneGap desktop app, which you just saw. What's nice about this is when it's connected to the desktop app or the PhoneGap CLI, it supports live reload. So as changes are made to your code, the PhoneGap developer app can recognize those and reload. It comes with a selection of third-party plugins and also comes with all the core plugins already installed. This again makes it easy to get started with PhoneGap, as you don't have to have a local development environment or local SDKs installed. Let's go over the pros for PhoneGap Desktop and PhoneGap Developer. Both have no prerequisites, so it's easy to install them and get started with them. It means that it's easy for you to get a good feel for PhoneGap without having to install everything. It's great for quick mock-ups and proofs of concept. There's no building involved. Results are served from PhoneGap Desktop or the PhoneGap CLI and run directly on the mobile device via the PhoneGap Developer app. This means that no local SDKs are required. Again, this means that it's easy to get started. Because there's no building, it's also faster to reflect changes that you might be making to your codebase. Live reload goes hand in hand. Changes that you make to your codebase can be nearly instantaneously reflected on the device. Rapid iteration is just that, rapid. It also makes it easy to test your app on a physical device. The device doesn't need to be tethered via a USB cable. It just needs to be on the same network as your development machine. It also means that the device doesn't need to be registered with anyone, which is a benefit when you're testing iOS apps. As with all things, nothing is perfect. The PhoneGap Developer app only supports core and some third-party plugins. If you need others, you either have to build the app yourself, which means you need the local SDKs, or do without. The PhoneGap Desktop app doesn't offer plugin or platform management, so there's nothing that lets you add a platform, change a plugin version, or anything like that. That is delegated to the CLI. Unfortunately, edge cases abound. The PhoneGap Developer app is itself a PhoneGap app. So PhoneGapception, really. The PhoneGap Developer app has its own config.xml, which means yours is ignored. It has its own whitelist, which means yours is ignored. The PhoneGap Developer app has its own application bundle, and again, which means yours is ignored. Because the PhoneGap Developer app also supports gestures as its interface in terms of reloading and navigating back to the home screen, it also means that those gestures might be intercepted by the PhoneGap Developer app instead of yours. Unfortunately, it's also not a true reflection of how the app will function or work when built using the CLI or PhoneGap build. This is largely due to these edge cases, and in almost every case, it's because a setting in config.xml is being ignored, and because of this, it was working in the developer app, but not when built. So it's always important, if you're going to use the PhoneGap Developer app, to double check all the config.xml settings, make sure all plugins are added appropriately, so that your app still functions when it's built. Unfortunately, debugging options are more limited with PhoneGap Developer. This is because in order for it to be deployed to an app store so that you could install it, it's built in a release mode. And release apps cannot be debugged using Chrome or Safari. As such, you're limited largely to alerts or other tools that try to emulate a debugger in Chrome or Safari. That is, unless you build the PhoneGap Developer app yourself. But if you're going to do that, and it's fine if you do, you're still going to need the local SDK, in which case you may as well be building using the PhoneGap CLI. So what is the PhoneGap Developer and Desktop app good for? It's great for getting a feeling for PhoneGap. You might not be entirely certain that you want to use PhoneGap for your project, in which case this is a great way to see if things will work out. It's great for rapid iteration. Building is slow. Now, I'm not talking about minutes slow, but every second matters. And it can be frustrating at times to make a small change and then run through your entire build process to see what the result looks like. It's easy to test on devices. There are no signing requirements, and you don't even have to be a member of a development program. This makes it easier to test rather than having to go through an SDK, build, and deploy. Devices don't need to be tethered to your development machine either. When tethered, it implies that devices are within your vicinity. However, any device on the same network as the PhoneGap CLI serve or the PhoneGap desktop app can connect. So you could have many different people testing your app as long as they're on the same network. It's also great for testing your user interface. In this section, we went into more depth with the PhoneGap CLI. We explored what PhoneGap Build is and why you might be interested in it. We also discussed the PhoneGap desktop and developer app faces. In the next section, we're actually going to get down and dirty and install all the prerequisites necessary for PhoneGap. We'll start by downloading and installing Node.js. See you then. Welcome to Section 4, Downloading and Installing Node.js. In this section, we're going to take a look at the following things. First, we're going to install Node.js on macOS, in my case, El Capitan. Next, we'll look at installing Node.js on Linux. Again, in my case, we'll be using Ubuntu 16.04 long-term support. Finally, in this section, we'll look at installing Node.js on Windows 10. In this first video of Section 4, we're going to look at installing Node.js on macOS. Specifically in this section, we're going to take a look at the system requirements that you'll need, not just for this video, but for the remainder of the course. We'll also look at the easy way to install Node.js, and we'll discover why it is a problem. Finally, we'll finish up with the better way, using a tool called NVM, or Node Version Manager. These are the minimum and suggested system requirements that your system should have for this video and the remaining videos in this course. You need a Mac if you're going to be creating iOS apps. Your Mac needs to be fairly recent, capable of running macOS 10.10, or Yosemite as it's more commonly known, or better. You also need macOS 10.10 Yosemite or better installed. It sounds like this is duplication, but technically there are ways around having a Mac, but these are all unsupported and runs afoul of the license. You need at least 4 gigabytes of RAM. 16 gigabytes is suggested. You need a 1440 by 900 display, or better. You also need 32 gigabytes of drive space free, or better. My system is a MacBook Pro 15-inch Retina. It's running macOS 10.11 El Capitan. It has 16 gigabytes of RAM and has a 2880 by 1800 display resolution. I highly suggest having an SSD or solid-state drive. This makes installation and building your apps a lot faster. Installing Node.js, the easy way, consists of 3 steps. First, go to the Node.js website. Download the installer, and then execute the installer. First, we go to the nodejs.org website. Next, we click on the download button for the version that we want. If you want something that is well supported for many years, you might want to choose the LTS version, long-term support. If you're bleeding edge, choose the current version. Next, we want to execute the installer that we just downloaded. We can check which version is actually installed on the system using these 2 commands. So that was easy. Unfortunately, it means that you'll have problems down the road. For one, although you'll not notice it in this course, you can only have one version of Node.js installed at any given time. A bigger problem is the fact that you can't install global packages without administrative rights. Here's an example of what happens if you try to install a global package. In this case, we're installing Cordova globally. This is the kind of error that you would receive. It's a permission denied error. The user currently installing the global package doesn't have access to the node modules directory in a system-level directory. You could run this command again as root or administrator, but that's a bad practice. Instead, NVM or Node Version Manager is a better way. NVM is short for Node Version Manager. The source is available at the link on the screen. It's not an officially developed package by Node.js, but it's become standard on Unix and Linux systems. The benefit of NVM is that you can switch between Node.js versions at will. In other words, you can have multiple versions of Node on your system. Each Node.js version will have its own global packages as well. It also makes it easy to upgrade to new versions of Node.js. And there are no administrative rights required to install global packages. Like before, the first thing we do is navigate to the website. Installing NVM doesn't use a typical download button. Instead, it provides a command we can use on the terminal. I don't generally like running commands from a web page that are going to immediately start downloading and installing things. Instead, we're going to redirect the output to a local script that we will then use VI to investigate. You are, of course, free to use any editor you desire to review the script. It is highly suggested that you ensure that it's not going to do something bad or malicious to your system. When you're satisfied, you can then proceed to execute the script. You may encounter this error when installing NVM, especially on a fresh install of macOS, or if you've never installed Xcode or the command line developer tools before. Just click Install, and the command line tools will install for you. Once installed, you can run the install script again for NVM. You'll notice that, in this case, it ended in an error message. It's because this is a fresh install and our user doesn't have a profile script created. NVM completes the install, but it goes ahead and errors out. Thankfully, it tells us exactly the commands we need to add to our profile. First, we copy these 2 lines, and then we will open up our profile and paste the lines in, like so. Next, we source our profile, or reload our profile, so that the changes take effect. Now we can run NVM. Without any parameters, it shows a lot of help. To get the available versions of Node.js that we can install, we can use NVM ls remote. We can then install whatever version we choose by using NVM install. Again, we can check the versions that were installed by using node -- version or npm -- version. It's a good idea to edit our profile so that we can always use the default version we just installed. You could, of course, also edit the profile to use a specific version if you had multiples. Now, when we source our profile, it will tell us the version of Node we're currently using. It will also do this whenever we create a new terminal. In our next video, we'll cover installing Node.js on Linux. In this video, we're going to look at installing Node.js on Linux. In this video, we're going to look at the system requirements and how to install Node.js via NVM or the Node Version Manager. We aren't going to cover installing Node.js via any other method in this and the next video. If you want to see why, please refer back to video 4.1 to get a full understanding of why we're doing this. The system requirements are as follows. You need a 64-bit distribution of Linux that is capable of running 32-bit apps. You can use either GNOME or KDE, and you need the new C library 2.11 or better. You should have at least 2 GB of RAM, but 16 GB is preferred, and a 1280 by 800 display resolution or better. You also need 32 GB of space left on your drive, or better. If you don't have curl installed, you'll also need that to complete this installation. You can install it using the command shown on the slide. My system in this case is a virtual machine. It's running Ubuntu 16.04 long-term support 64-bit. I configured it with 4 GB of RAM, which was sufficient for my purposes in this video, but I'd highly suggest more. My virtual machine was also limited to 1280 by 720 display resolution. This is not ideal, as some dialogues will tend to overflow the screen. Really, the more display real estate you have, the better. I also equipped this virtual machine with a 64 GB volume. I should also mention that Ubuntu 16.04 meets just about all these requirements out of the box. It comes with curl already installed, and it's a 64-bit distribution. There's one prerequisite which we'll need to install later for Android Studio, but we'll cover that in the appropriate section. Now let's install NVM on Linux. If you've watched the previous video in this section, then this slide should look familiar to you. If not, let me touch on these points real quickly. The Node Version Manager is a way to run multiple versions of Node on the same system. It can switch between these Node versions at will. Each version has its own global packages. NVM also makes it easy to upgrade to new versions of Node.js, and there are no administrative rights required to install packages. The benefit of NVM is that it remains local to the user's account. It doesn't mess around with system-level directories or files. First, we need to navigate to NVM's website. NVM doesn't present a typical download button. Instead, it provides a command that we have to execute in the terminal. I don't suggest running these commands without first evaluating what the script will do. And so, in this example, we download the script to a local file and then examine it with VI. You can use whatever editor you would like to examine the script. Once you are sure that it's not going to do anything malicious to your machine, we can then execute the script to install NVM. If you recall in the previous video, this script failed when there was no profile to add these 2 lines to. I'm going to go ahead and copy them here just in case, but in our case it actually did add them to our bash rc file. Even so, it's a good idea to double check that they are in fact there. Next, we need to verify that we can run NVM. You'll note that I exited the terminal session before trying to do so. You could have also just sourced your profile again. Next, we list the remote versions of Node available so we know which one we want to install. Then, we install it using NVM install and the desired version number. Next, we add a line to our profile so that NVM will run whenever we log in. We'll tell NVM to load up the default version of Node. This has the benefit of telling us which version of Node we're using when we start a new session. Although not required for this install, it's also a good idea to make sure that Git is properly installed on your system. You can do so using sudo apt get install git. In the next and final video of this section, we will install Node on Windows. In this final video of this section, we're going to take a look at installing Node.js on Windows. In this video, we're going to take a look at the system requirements you'll need, how to install Node.js using NVM Windows, and how to install Git. You will need Windows 7, 8, or 10, preferably 64-bit. You should have at least 2 GB of RAM, if not more. 16 GB is preferred. You should have at least a 1280 by 800 display resolution and 32 GB of drive space free. My system is a virtual machine running Windows 10 64-bit. I gave it 4 GB of RAM, which was sufficient for my purposes in this video, but typically you'd want to allocate more. The display was limited to 1280 by 720. This is not ideal, and preferably the more real estate you have, the better. I also gave the virtual machine 60 GB of drive space. NVM, or Node Version Manager, is great. It's what we've used to install Node on Mac and Linux thus far. Unfortunately, it's not available on Windows. The alternative is a product called NVM-Windows. It's not perfect. It requires administrative rights to use effectively. But otherwise, it's a very good approximation to what NVM is. You can download it at the link on this slide. The steps to install are pretty easy. All we have to do is download the installer, execute it, and then we can install Node. First, we navigate to the website in order to download NVM-Windows. The download link is a little bit lower on the page, so you will need to scroll down to locate it. Next, we download the version of NVM-Windows that we want, in this case, the latest release. Now we need to open the folder that the file was downloaded to. NVM Setup is an archive, so we need to extract it before we can install it. Now that we've extracted it, we can install it using NVM Setup in this new folder. When installing this, you can just accept the defaults. Like on the Mac or Linux, we can use NVM by opening a command line prompt. Unfortunately, NVM doesn't work unless a command prompt was started with administrative privileges. Here, I chose to pin the command prompt to the Start menu, since this is something that you'll be using often. Now we can start the command prompt with administrative privileges. At this point, NVM itself will work correctly. Next, we can list the available versions of Node to install by typing NVM list available. We can then install the appropriate version by using NVM install. To verify that everything installed correctly, we will tell the system to use the version we just downloaded, and then we'll check the version numbers to make sure they match. Next, we need to install Git. You can download this from git-scm.com/downloads. Once the download is complete, we open the folder that it was downloaded to, and then we can execute the installer inside. For the most part, I accepted the defaults as they were presented. This was the only setting I changed. Instead of using min-tty, I opted to use Windows default console window. On Windows 10, it is much improved over previous versions. On Windows 7 or 8, you may still wish to use min-tty. Finally, let's make sure that Git installed properly. We should be able to do this by opening a command prompt under Administrative Privileges and executing the Git command. In this section, we've covered the download and installation of Node.js on 3 operating systems: Mac OS, Linux, and Windows. This applies only if you're going to be building iOS apps, as this requires Mac OS and Mac hardware. Welcome to Section 5, Downloading and installing Xcode. In this section, we're going to take a look at the following. First, we'll download Xcode. Second, we will install and configure Xcode for development. In this first video of Section 5, we're going to show you two ways to download Xcode. First, you can download Xcode from the App Store. You'll need an Apple ID to complete this download method. Second, you can download Xcode from Apple's developer portal. To do this, you'll need to have a developer account with Apple in order to complete this step. You can obtain your Apple ID at appleid.apple.com. Obtaining an Apple ID is absolutely free. If you want a developer account with Apple, you can enroll at developer.apple.com/programs. The individual developer account costs $99 per year and enables distribution to the App Store. Technically, you don't need to enroll in the developer program just yet. Most of the videos don't require it. However, by the time we get to deploying our app to the App Store, you will need to be a member of this program. Let's get started and download Xcode from the App Store. Once the App Store is launched, click the Categories icon at the top of the window. Then, click the Developer Tools category. Then, click the Xcode icon or text. Now, click the Get button and then click Install App. At this point, you'll be prompted for your Apple ID. If you don't have one, you'll need to create one before you can continue. There is another way to download Xcode. It's useful when the App Store gets stuck and refuses to completely download Xcode. I've had this happen to me on occasion. As such, it's useful to know about this trick. You can go to developer.apple.com and then, when the website has loaded, you'll want to click the Develop tab at the top. Next, click the Download icon. At this point, you'll need an Apple ID that is enrolled in the developer program. After you sign in, you'll be taken to a list of mini downloads. Scroll down to the bottom of the page. And click See More Downloads. Now there's a lot of downloads here, so I usually filter first by Xcode. Then I can scroll through the list to find the version of Xcode I want to download. In this case, I'm going to download Xcode 7.3.1. As you can see, Xcode is quite large, so it might take some time to download. Once it's finished, you can open Xcode in the Finder. You can then open the disk image. It will take some time to verify the disk image. At this point, you can copy Xcode to the Applications folder simply by dragging the Xcode icon over to the Applications folder. This will decompress the Xcode package. This will take some time, so don't be surprised if you need to get another cup of coffee. At this point, you've successfully downloaded Xcode. In the next video, we're going to finish the installation process and get Xcode configured for development. Welcome to the second and last video of Section 5. In this video, we're going to go over configuring Xcode. In this video, we're going to look at the following: how to launch and configure Xcode, how to use devices for development, and note that you'll need an Apple ID to complete this process, and how to launch simulators. First, launch Xcode. You can do this using Launchpad, Spotlight, or from the command prompt. In this example, I'm going to launch Xcode from the Launchpad. Since this is our first launch after downloading Xcode, Xcode is going to insist on verifying itself. This is going to take some time depending upon the configuration of your system. In my case, this took about 8 to 10 minutes. So if you're into coffee, you might want to go brew some. Once the verification process is complete, macOS will prompt you to make sure that you want to open the app since it's downloaded from the internet. In our case, we're really sure that we want to open it, so go ahead and click Open. Don't be surprised if Xcode hangs here for a moment or two. Notice the spinning cursor of doom. Also, for some reason, Xcode in this case decided to open the next window below the terminal, so notice Xcode's icon is jumping up and down. When this prompt appears, go ahead and click Install. And if you're like me and like music, you'll also have to close down iTunes. When prompted, enter your administrative password. And then wait while the components are installed. Now that Xcode is up and running, we need to properly configure it. It's a good idea then to open the Xcode menu and then click Preferences. You're welcome to change any of these settings that you desire, but typically we don't live in Xcode very often. So you don't need to worry about changing things for text editing or fonts and colors. What we are most interested at the moment is the Components section. In the Components section, you can download many different versions of the iOS simulator. Now, Xcode comes pre-installed with the latest version of iOS simulator, but it's a good idea to download others if you want to test on older versions of iOS. Keep in mind, however, these are pretty large, so make sure that you have sufficient disk space available. Xcode comes pre-installed with a lot of documentation. It's really only of use if you're writing native code or writing plugins. You can also download guides and sample code from Apple, which again is only of use if you're going to write native code. Next, in order to properly use Xcode, you'll need to tell it what your Apple ID is. You can add an Apple ID by clicking the Accounts tab and then clicking the plus icon in the lower left corner, followed by clicking Add Apple ID in the pop-up menu. Next, sign on using your Apple ID. If you don't have one, you will need to obtain one in order to complete the steps in this video. Once done, go ahead and close down the Preferences dialog. If you have a physical device, now is the time to configure it for operation with Xcode. To do so, open Window and then click Devices. Now, go ahead and connect your device physically to the computer. Chances are pretty good that when you do this, Apple's Photos app will start up. Go ahead and close it down. Also note that iTunes wants my attention, and again, for some reason, it's bouncing instead of presenting the appropriate window to me. So if it's bouncing on your system, go ahead and click it, because it's asking you something pretty important. Click Continue. At this point, on my phone, there's a dialog that's asking me if the phone should trust this computer. Go ahead and click Trust in this case. A few moments after you do so, the dialog that's currently on the screen will disappear. Now, go ahead and click on the new device that appeared in the sidebar. You'll notice that Xcode says it's currently busy. It's currently downloading symbols from my phone. Depending on the speed of your phone and your system, this might take a few minutes. Now that Xcode knows about your phone, go ahead and close the Devices window. Now, to make sure that we can actually deploy apps to our device, I'm going to create a new simple project in Xcode. To do so, I need to bring Xcode back to the front, and then it will display the Welcome to Xcode dialog. Next, I can click Create a new Xcode project. I'll use the Single View Application template. Now I'm going to provide just an example product name and organization identifier. And then I'll tell Xcode where I want this project to live. If Xcode asks you this question, it's up to you whether or not you want to allow this or not. In my case, I chose Don't Allow. We need to tell Xcode which team to use to sign our apps, even if we're only going to be debugging them at the moment. Select the team dropdown and then select your name that corresponds to Personal Team. At this point, Xcode may fail to create the necessary provisioning profiles. In my case, it's because the currently selected device is an iPhone 7 Plus simulator. There's no reason to create provisioning profiles for simulators because they don't need them. But for a real device, they do. Let's go ahead and switch to my connected device. Notice that the signing certificate is now valid and matches my Apple ID. Next, let's try to run the simple app on my phone. To do so, I need to click the play icon in the upper left corner of Xcode. At this point, Xcode will ask if you want to enable developer mode on this Mac. Go ahead and click Enable and then enter your administrative password. And now, wait for Xcode to build the app and deploy it to your device. As you can see, the attempt to launch the app on our phone fails. This is because the phone doesn't currently trust the provisioning profile that Xcode just created. To fix this, on your phone, open the Settings app and then navigate to Profiles and Device Management. Then tap on the row with your Apple ID in it. On the following screen, there will be a button labeled Trust. Go ahead and tap that. This is all you should have to do on your phone at this point. Now, go ahead and click OK, and let's try to run the app again. At this point, your phone should be displaying a white screen. It's nothing exciting, but it does verify that Xcode can now properly deploy an app to your device. At this point, I should also note that if your Apple ID is associated with a developer program account, the process is largely the same. Xcode will detect this and set it up appropriately. Next, let's verify that we can start up a simulator as well. To do so, we can click Xcode, then open the Open Developer Tool menu and click Simulator. Now, an iOS simulator will begin to boot. This particular iOS simulator is presenting in the iPhone SE form factor. You can change what kind of device the simulator simulates by going up to the Hardware menu, opening the Device submenu, and then selecting the device you wish to simulate. In this section, you downloaded and installed Xcode. You also configured Xcode and set up devices and simulators. In the next section, we'll focus on downloading and installing Android Studio. Welcome to Section 6, Installing Android Studio. In this section, we're going to take a look at the following: installing Android Studio on Mac OS, installing Android Studio on Linux, and installing Android Studio on Windows. First, let's install Android Studio on Mac OS. In this video, we're going to take a look at the following things. First, we'll install Homebrew, a package manager for Mac OS. Then, we'll install the Java 8 JDK or Java Development Kit. Next, we'll install Android Studio. Then, we'll configure the necessary environment variables that you'll need in order to develop with Android Studio. And finally, we'll create an Android virtual device, otherwise known as an emulator. Our first step is to install Homebrew. This is a package manager available for Mac OS, available at brew.sh. This website will provide a command that installs it automatically. This command is visible on the screen. I don't like this method of installation, but unfortunately that's what Homebrew uses. If you're unsure about the safety of the content that is going to be downloaded, you can instead download the install script and then examine it at your leisure. When you're sure it's safe, you can execute the command to install. This is the Homebrew website. Notice the command in the middle of the screen. This is the command that we can copy and paste into the terminal prompt. When prompted, enter your user's password. This is because Homebrew requires administrative rights in order to complete the installation. Now that Homebrew is installed, installing Java is easy. We can install it by simply typing brew cask install Java. We will need to configure our Java home in the environment, however. We'll cover this near the end of this video. Again, when prompted, enter your user's password. Java also requires administrative rights to properly install. At this point, Java is successfully installed. At this point, we can proceed to install Android Studio. Homebrew makes it easy to install Android Studio as well. We can just type brew cask install Android-Studio. Then we can open Android Studio using whatever launcher you prefer or the command prompt. Then we can follow the configuration prompts. And then we'll need to install API Level 23 along with system images so that we can actually compile against an Android image and launch an Android emulator. At this point, Android Studio is installed, but it's not configured yet. To go through the first-time configuration steps, we need to launch Android Studio. In my case, I'm going to launch Android Studio using the command line. This initial prompt is what you'll see when you start up Android Studio for the first time. In this case, I'm just going to select I don't have a previous version of Studio. But if you had a previous version installed, you could import your settings from that previous version. Next, Android Studio is going to ask us some questions about how we want our environment to be configured. In my case, I took the custom install type. Here, I accepted the default. I typically don't use Android Studio to edit my PhoneGap apps. If you do, choose whichever theme makes sense for you. On this screen, make sure to note the Android SDK location. We will need it for later. Otherwise, the defaults are acceptable. On some systems, Android can run the Android emulator in a performance mode. This requires installing additional software and requires some configuration to make it work properly. In my case, I just accepted the defaults. This screen will show you the current chosen settings, along with total download size. At this point, click the Finish button to begin the configuration and installation of the SDK components. At this point, you might as well get yet another cup of coffee. It's going to take some time to download the components. Through the magic of video editing, you didn't have to wait nearly as long as I did to download these components. Click Finish. We've still got more configuring to do. Next, click Configure and select SDK Manager. At the bottom right of the screen, check Show Package Details. Scroll down to the Android 6 Marshmallow section. We need to install some SDKs and system images if we're going to create PhoneGap apps against Android. Note that there are several system images. There's an ARM system image, there's an Intel x86 system image, and a 64-bit version of that image as well. The Intel x86 Atom images are intended for accelerated emulation. This is only possible if your machine will permit it. The ARM system image is also much slower than the Intel x86 Atom system image. Avoid using the ARM image if you can. It takes forever to start and is much slower than the other images. Click the Apply button, then click OK. Accept the license agreement, and the components will begin to download. You might want to get another cup of coffee at this point. Now that that's done, you can click Finish and then close out of the SDK Manager. In order for PhoneGap to be able to compile an Android app, the environment needs to be properly configured. To do this, we need to get the SDK path from Android Studio and then export that path from our profile. We can then verify that the environment is correct by typing the command Android at the command prompt. The Android SDK Manager inside Android Studio can provide the Android SDK location. We can then copy this to the clipboard. Next, we open our profile so that we can configure the environment properly. Here we export two additional locations in the system's path: Platform-Tools and Tools, both of which are directories located in the Android SDK that Android Studio downloaded for us. In my case, my editor decided to split these up onto two lines. Make sure that this is a single line. Next, we need to export the location of the Java JDK that we installed earlier through the environment variable called java_home. This executable in user libexec automatically returns the appropriate Java home for us. This means we don't have to hard code the path to the JDK. At this point, we can test to make sure that our settings are correct. Before we do, however, you'll need to either close the session or resource the profile. Executing Android at the command prompt launches the Android SDK Manager. This is similar to the tool in Android Studio. However, you should double check to make sure that the system images are appropriately installed. In my case, they disappeared, so I have to download them again. Just like before, we have to accept the license before they will download. Now that the system images are downloaded again, we can close the Android SDK Manager. This proves that our environment settings are correct. Next, we need to create an Android virtual device. We're almost there, I promise. The Android virtual device is so that we can test our apps on an emulator, especially important if we don't have the physical device in hand. We can launch the utility to create these AVDs by typing Android AVD. Once the AVD Manager appears, we click the Create button. There's a lot on the screen. First, we name our AVD. This can be anything you want. Then we select a desired device. Select one that fits within your screen size. Next, we select API level 23 and choose the desired CPU type. We don't use a skin, and the front and back cameras are emulated. Select a small SD card size, and then you can choose to use the host GPU if you aren't running in a virtual machine. When you're satisfied with these, you can click OK to create the virtual machine. One note on using the host GPU: if your machine doesn't support this, running the Android virtual device will probably crash. So if you can't run your Android virtual device with this setting checked, try unchecking it and try again. The Android Device Manager then shows you the results of creating this AVD. Click OK. To launch an AVD, select it in the list and then click the Start button. Next, click Launch. Unfortunately for me, the accelerated environment didn't work, mainly because I was already running another virtual machine on my system. So I'll set up the slow AVD using the ARM CPU instead. It'll take longer to start up, but at least I'll be able to show you what it looks like when it's running. Note that Android is complaining because we're using the ARM CPU, which is a lot slower. But for me to show you an example of what it looks like, this is what I had to do. Voila, it works! You can tell that Android is running inside the emulator. Now, to be fair, I sped up the start process by quite a bit. Using the ARM CPU, it can take several minutes to get to this point. Well, that was a lot of work. But now we have Android Studio installed and an Android SDK properly configured. We can also start up an Android virtual device which we'll use later to test our apps on. In the next video, we're going to do the same thing, only with Linux. Welcome to this second video of Section 6. In this video, we're going to install Android Studio on Linux. In this video, we're going to take a look at the following. We're going to download Android Studio, and then we're going to install the Java 8 JDK. Then we'll install Android Studio and configure the necessary environment variables. Finally, we'll create an Android virtual device. This will let you test your apps on an Android emulator. First, a few prerequisites. If you are running on IPv6, you may wish to switch to IPv4. I encountered some difficulties when running on an IPv6 network. Some of the libraries needed for Android Studio to work correctly did not want to download correctly. If your distribution is 64-bit, make sure to install 32-bit support libraries. The command is on the slide. If you fail to do so, parts of Android Studio will fail when trying to install parts of the Android SDK. If you haven't already, make sure to install Git. If your CPU supports accelerated virtualization, you can install KVM. First, be sure that virtualization is enabled. You can consult your computer's manual for instructions on how to do this. Keep in mind, if you're running a virtual machine, chances are you won't be able to use accelerated virtualization inside the virtual machine. This is my Ubuntu virtual machine. First, I'm going to add 32-bit app support to my 64-bit distribution. Next, I'm going to install KVM and check if my machine supports accelerated virtualization. Hint, it's a virtual machine, so it won't, but this will show you the steps for you to check. Now that KVM is installed, we can check if we can use it with a simple command. Unfortunately, my virtual machine does not support KVM extensions. Hopefully, your machine does. Otherwise, Android virtualization is going to be very slow for you. Next, we're going to download Android Studio. The website is on the slide. Once we navigate to the web page, we can click Download Options and then click the download link. Accept the terms and conditions, and then save the file to your computer. Now we need to install Java. If you don't have it already installed, installing it is easy. Do make sure to install Java 8 JDK or better. Note, the command I'm using installs the OpenJDK. Android Studio will complain a little bit that it isn't completely compatible. So far, however, I've had no problems using the OpenJDK. First, we used apt-get to install the default JDK. This will install a Java 8 JDK for us. Next, we need to configure the environment so that it knows where Java is located. To do this, we can run another command to tell us the location of Java. I'm just going to copy this path to my clipboard. Then we'll edit the bashrc file. We will export an environment variable called java_home. At this point, Java should be properly configured. It's always a good idea to make sure that Java is accessible, so we can run a command that prints the version. Now we're going to install Android Studio. We'll unzip the download, and then we will execute Android Studio. Because this is the first time we are running Android Studio, it will ask us some configuration settings. Then we will install API Level 23 along with system images to support emulation. I happen to download Android Studio to the Downloads directory. Now I will extract the archive into the download directory. This isn't where I want Android Studio to live permanently, so I'll create a different directory and then move Android Studio to it. Now that we've placed Android Studio where we want it to live, we need to open our terminal to start it. Because this is a fresh install, I'll accept the default of I do not have a previous version of Studio. If you had previous versions, you could import their settings instead. This is the configuration screen for the first start of Android Studio. You'll notice in the upper right corner that it's complaining that we're not using an Oracle JRE and JDK. However, I've yet to have any problems with Android Studio using the OpenJDK. Your mileage may vary. If you're comfortable with the default settings, you can choose the standard setup. I like to go through the custom setup to see what options I have. Here, choose whatever syntax highlighting scheme you prefer. You can accept the defaults on this screen for now. We will be downloading API Level 23 for Android 6 Marshmallow in a moment. Be sure to remember the Android SDK location noted in the lower left. On this screen, Android Studio will tell you what it's about to download. Go ahead and click Next. This is why we installed KVM earlier. If your machine is capable, your Android emulator will be much faster. If your machine is not, then prepare to exercise your patience. Now that Android Studio is configured, we need to download API Level 23. This corresponds to Android version 6 or Marshmallow. Note that there are several system images. You'll want to choose the one that works for your system. If you are able to use KVM, choose the Intel x86 Atom 64 system image. If you aren't able to use KVM, choose the ARM system image. Next, we need to configure the environment variables. This is so that PhoneGap will know how to compile Android apps. We've already obtained the SDK path from Android Studio. Next, we'll open bashrc and export two new paths, and then we'll verify that the environment is correct. There are two directories we need to export in our path. The first is the Tools directory, and the second is the Platform Tools directory. Before we can test, we need to exit our terminal and relaunch it so that it sees the new environment. To test, we can execute the command Android. You'll notice that the Android SDK Manager here looks a lot like the one in Android Studio. Double check here, however, that the system image we installed in Android Studio made it through. In this example, for some reason, it did not, so you'll want to double check on your system. If it didn't, just download it again. Now that we've installed Android Studio and configured the Android SDK and downloaded the system images, we can create an Android AVD, or virtual machine. We do this by typing Android space AVD at the command prompt. Then we can click Create, enter the desired device features, and follow the prompts to finish the creation of the AVD. Select whatever device you would like to emulate. In this case, I'm going for a smaller screen so that it fits on my virtual machine. To start your virtual device, select it and then click Start. If you're using the ARM CPU type, like I am, this is going to take a while. At this point, the Android emulator is running. I'm not going to show you the complete boot sequence since you've already seen that in the previous video. In the next video, we'll install Android Studio on Windows. Welcome to this final video in Section 6. In this video, we're going to install Android Studio on Windows. In this video, we're going to look at the following. We're going to download Android Studio, install the Java 8 JDK, or Java Development Kit. We'll install Android Studio. We'll configure the necessary environment variables. And finally, we'll create an Android virtual device, or an Android emulator. Our first step is to download Android Studio. To do this, we will navigate to the link on the slide, and then we'll download the Windows version. Any of these versions will suffice for our purposes. However, I will download the one in the middle. Now that we've navigated to the download page, we need to scroll down until we see the available Windows downloads. Either of the first two options are probably your best option. These both come with installers to make it easy to set up Android Studio. The third option, on the other hand, doesn't come with an installer, so it's a little more complicated to set up. I'm going to skip downloading the initial Android SDK and go with the middle option. Before we can download Android Studio, we need to accept the terms and conditions. Now that we've downloaded Android Studio, we need to install Java 8 before we can install it. Android Studio requires Java 8 or better. If it's not already installed, we'll navigate to the link on the screen and we'll download and install Java. Although not displayed in the following recording, you will probably need an Oracle account. You can create one of these for free. The installation process itself will use a typical Windows installer, so it's pretty easy to follow. In fact, the Android Studio download page links directly to it, so we can use that link as well. After accepting the license agreement, be sure to select the version of Java appropriate for your Windows installation. Next, let's open the folder where we downloaded Java. The folder might open behind the browser, like it did in my case, so double check if it doesn't appear to be doing anything. Then double-click on the Java installer. You'll need to answer yes to allow Java to install. The installation is a typical installer. Go ahead and follow the steps. In this case, click Next. Accept the defaults on this screen by clicking Next. This is about the only difference between a typical installer. For some reason, you're prompted again to select where you want to install Java. Go ahead and accept the defaults by clicking Next. Now that Java is successfully installed, go ahead and click Close. Now that we've downloaded Java, we can install Android Studio. To do so, we'll double-click the downloaded executable, follow the installation prompts, and then we'll run Android Studio and follow the configuration prompts. Finally, we'll download API Level 23 along with system images. Back in our Downloads folder, we'll double-click Android Studio IDE. As with Java, you'll need to allow the app to make changes, so click Yes. Go ahead and click Next on this screen. We'll accept the defaults on this screen, so again, click Next. If you intend on installing Android Studio elsewhere, now is the time to do so. Otherwise, click Next. Again, accept the defaults and click Install. Now that the installation is complete, click Next. Now click Finish. Notice that Start Android Studio is checked, which means Android Studio will start automatically. Yet again, Windows decides to open it beneath all my open windows. So if your Android Studio isn't coming up, check your taskbar. Unless you've had a previous version of Android Studio installed, go ahead and accept the defaults and click OK. Click Next. I like to install a custom installation. You can choose either option. Go ahead and accept the defaults here. Next, Android Studio is going to download the Android SDK. Notice it doesn't give us the option as to which version of the SDK to download. It's going to download the most recent. In this course, however, we're going to want to download API 23, a slightly earlier version as well. Go ahead and click Next. On most systems, you'll be able to run the Android emulator with accelerated performance. To do this, you'll need to allocate a specific amount of memory for the Android virtual device to run with. Select an amount not more than, say, half of your installed memory and click Next. Android Studio is going to tell us what it's going to do. Accept these defaults and click Finish. Now that it's finished, go ahead and click Finish. Next, click Configure and then SDK Manager. We want to download Android 6 API, so check Android 6. Now click Show Package Details in the lower right-hand corner of the screen. Scroll down and add a system image. Select a system image appropriate for your system. In most cases, you'll want the Intel x86 Atom 64 image. For systems that don't support virtualization, select the ARM image instead. Click Apply, click OK, and then accept the license agreements and click Next. Next, we need to configure the environment variables for the system. If you don't remember the SDK path, you can get it from Android Studio. Next, we'll edit the path environment variable and other environment variables as well. Then we'll verify that the environment is correct. First, we need to open the System Environment Variables dialog. The easiest way on Windows 10 is to use Cortana. Next, click Environment Variables in the lower right-hand corner of the dialog. Next, we need to create a new user variable that says where the Android SDK lives. Click New and create a variable called Android_home. Be sure to point to the correct Android SDK location. When finished, click OK. On this dialog, find the path system variable, select it, and click Edit. Double-clicking the item works as well. In case it's not already present, I'm going to add Node.js to our path. Click New and add the path as shown. We also need to add items that point to the Android SDK. There are two, Tools and a Platform -Tools. You can click OK to close the dialog. You can close out of the Environment Variable dialog by clicking OK. Next, launch a command prompt. We're going to verify that everything is installed and configured correctly. First, make sure that we can execute Node, and then make sure the SDK is accessible by typing adb-help. Now that we've installed everything, we need to create an Android virtual device. You should always check to make sure that the system images are present first. You can do this by typing Android at the prompt. If they aren't installed, go ahead and download them. Then you can open the Android Virtual Device Manager by typing Android AVD at the prompt. Then click Create, enter the desired device features, click OK and OK again, and then you have an Android virtual device. To start it, you can select it and click Start, then Launch. Let's show you how that works. In my case, the Android system images are already installed, so I'll type Android AVD, and the Android Virtual Device Manager appears. To create an Android virtual device, click Create, supply a name, and then fill in the relevant details. Select an appropriate device, make sure to pick one that fits on your screen comfortably, and then make sure the correct CPU type is selected. You can choose whatever size you want for the SD card, and you'll also need to pick camera options. I choose emulated. You should also, if you can, check Use Host GPU. Select a skin and click OK. Then click OK again. Select your Android AVD and click Start, then click Launch. And wait for it to start, hopefully. In my case, it didn't work because Intel HAXM, HAXM, is not properly installed, so we need to install that first. When Android Studio was installed, it copied this file to our system, but didn't install it. To install it, navigate to this location under your Home folder, App Data, Local, Android, SDK, Extras. Then click Intel and go into the Hardware Accelerated Execution Manager. Double-click on Intel HAXM-Android. Allow the app to make changes to your PC. And in my case, my virtual machine doesn't support it. For your machine, however, as long as it's not a virtual machine, it should. So just follow the standard installation prompts. Because my machine doesn't support it, I'm going to have to switch to the ARM CPU type. So I'm going to create another AVD. If, for whatever reason, the Android emulator hangs like this and never starts, it's because your computer doesn't like using the host GPU. Uncheck Use Host GPU in the settings and try again. At this point, Android is starting up. This means everything is correctly configured. These were some of our longest videos thus far. In them, we've installed Android Studio on 3 operating systems: Mac OS, Linux, and Windows. We're finally done with all the prerequisites necessary to install the PhoneGap CLI. So in the next section, that's what we'll do. We'll also explore the various project management commands the CLI has for us. Welcome to Section 7. We're going to explore the PhoneGap CLI. In this section, we're going to take a look at the following. We're going to look at how to install the Cordova and PhoneGap CLIs, and then we're going to look at project management. We'll also look at how you edit the config.xml file, which is what specifies configuration settings for your app. Finally, we'll explore the initial template. In this video, we're going to go over how to install the Cordova and PhoneGap CLIs. In this video, we're going to look at the following. First, we'll install a few prerequisites for iOS, and then we'll install the actual CLIs. You can install one or both. Both can coexist fine on a system, but you only need one or the other. First, let's install a couple of prerequisites. This is only required on Mac OS and if you are building for iOS. First, we need to install iOS Deploy. This is a utility that allows Cordova and PhoneGap to deploy apps to iOS devices. We also need to install another utility called iOS Sim. As the name implies, this helps Cordova and PhoneGap interface with the iOS simulators on your system. Of course, now that we've installed all the prerequisites, including the local software development kits, it's easy now to install the Cordova CLI. Let's install the Cordova CLI. It's easy. Note that there is a warning displayed during the installation process. You can safely ignore it. Installing the PhoneGap CLI is just as easy. Note that there are warnings displayed during the installation process. It is safe to go ahead and ignore these warnings. At this point, you've successfully installed the Cordova or PhoneGap or both CLIs. In the next video, we'll explore using these CLIs for project management, including creating projects, adding platforms to projects, and manipulating plugins within the projects. Hello and welcome to the second video in Section 7. In this video, we're going to focus on project management with the PhoneGap CLI. In this video, we're going to look at the following. We'll create a project using different methods. We'll manage the platforms within that project. And here, by platform, I mean iOS, Android, etc. And then we'll manage the plugins within the project. As you may remember, plugins allow us to use certain native features of the device. The first step of any project is to create it. The command to create it is pretty simple. PhoneGap create, or if you're using the Cordova CLI, Cordova create. 3 parameters are required. You need to supply a path to create the project. You need to supply an app ID in the form of a reverse domain. So, for example, where a regular domain is www.example.com, the reverse of that would be com.example.www. Then you need to supply an app name. You can supply a lot of other options as well, but let's start with this one first. So let's create our very first project. This parameter is the path. You can specify any path you want. Because I've not specified any forward slashes or anything like that, it will create it relative to my current working directory. I would suggest that you avoid paths with spaces in them. This is the app ID. This is the name of our app. It's user-facing, so make sure it's something that you're okay with the user seeing. This also means it should be pretty short. There's not a lot of room to display a title on most screens. When I press Enter, PhoneGap will create the project for me. Notice that it is retrieving a template for us. This is the default template that all PhoneGap apps are created with. It's not a complex template, however, it is sufficient to let us know if we've got everything configured correctly. Our project is now created. If we list our directory, we'll see it. Let's navigate to that directory. As you can see, the template that was just retrieved supplies a lot of files. You can use any number of templates. Here's how you find out what templates are suggested. As you can see, there are several templates here. There's actually several more available. This is what comes up when we search for templates. There's quite a few here. You can search through these at your leisure and find one that you like that most closely matches the project that you're trying to accomplish. Typically, I'll use either a blank template, such as this one, or I'll use a template that uses the framework that I'm going to use for the project. We'll discuss what frameworks are, why we chose a particular framework for our projects later, but we'll be using the Framework 7 framework, and so it makes good sense to use the Framework 7 template. So let's go ahead and create a project based on this template. First, I'm going to go ahead and remove the project I just created. Now I'll create a new one. Notice this time it indicates that it's retrieving a different template. Let's check out what we just created. Notice in this directory that there are some directories called platforms and plugins. Not every template will come with these already present. If they aren't present, the CLIs will create them for us. Let's go over how we manage platforms. First, it's helpful to see what platforms are available. Notice that this command, platforms ls or list, serves double duty. It tells us which platforms are installed in our current project, currently none, and what platforms are available for installation, and the suggested version. You can install any version that you want, including newer versions, but these are the ones that we know work with this particular version of PhoneGap. Adding any platform is easy. The command is PhoneGap platform add. You can supply one platform or many. You should also save these platforms in your project's configuration. We'll show you what this looks like in the configuration file in the next video. For now, the command is just to put in --save. PhoneGap will now download these platforms and install them in our project. You can see a lot of text scrolling by. These are plugins being added. These plugins were already present for part of the template that we just downloaded, and so they were installed automatically. Let's see what happened. At this point, it doesn't look like much, but if we navigate into the Platforms directory, we now have Android and iOS directories. These directories are where the native portions of our app will live. A copy of our www or web directory will also be placed in these directories, as will any versions that we build for deployment to emulators or devices. Now that we've added Android and iOS platforms, let's show you how to delete one. Deleting one is simple. PhoneGap, platform, rm, and the list of platforms you'd like to remove. Let's remove the Android platform. Now, as always, you should save this command. This will remove the platform from our project's configuration settings as well. Now that the platform has been removed, let's show you how it looks when we list the platforms. It's gone. Let's also show you what it looks like in the platforms directory. The Android directory is also gone. This means that there is a one-to-one correspondence between the installed platforms in your project and the platforms directories. However, you should never ever manually remove or add platform directories yourself. Let the CLI manage this for you. As mentioned before, you can install pretty much any version of the platform that you would like. But how would you do that? It's actually pretty easy. PhoneGap, platform, add, Android, and at this point it looks like the add commands we've done thus far. However, we can specify a specific version by typing an @ and the version number. Again, be sure to save it. Let's take a look at what that looks like now when we list the platforms installed. As you can see, version 5 of Android is now installed. As will probably be the case throughout your application's lifetime as you release future updates, the platforms themselves will also be updated. However, you need to update them yourself manually in your projects. You can start that process by using the update command. Let me show you how that works. Update, the name of your platform, and save. This will update back to the known working version of the platform specified by the current version of your CLI. In this case, it'll be version 5.1.1 of Android. Unfortunately, this is not your only step when updating your project for a new version of the Android or iOS platforms. Chances are good there will have been some change in the platform that might break your code. So, in those instances, you'll need to double check that nothing has been broken. 5.1.1 is the version that the CLI is comfortable installing by default. This changes with every version of the CLI you install. If you want a newer version of the Android platform, you can request it, however. You can do so by specifying the latest version. Notice that this time 5.2.2 was selected, and this is the most recent version as of this recording. And as you can see, 5.2.2 has been installed. You might be wondering how you would know which version is the latest. We can find this information out by querying npm. npm info Cordova dash and then the platform you're interested in our case Android, version. npm will now return the currently available version of Android. And as you can see, it's 5.2.2. What if you want to install a different version? How would you know what versions are available? You can simply pluralize version and turn it into versions, and you'll get a list. As you can see, there's quite a few. The nightlies are not finalized releases. They're there for testing purposes. But notice that there are 5.2.1, 5.2.0, 5.1.1, and 5.1.0, and even older versions. Typically, however, you'll either want to use only the latest version or the version suggested by the CLI. Once you start a project, the chances of you upgrading the platform are slim to none because you want a consistent environment to work against. You would only want to upgrade a platform if there was a bug or security issue that was addressed. Plugins are managed in a very similar manner to platforms. Let's see which plugins are currently installed. Now, unlike the platforms command, we don't get a list of available plugins. To know which plugins are available, you would need to open the plugin repository. We've shown this to you in prior sections. Adding a plugin is similar to adding a platform. Let's add a typically used plugin. The device plugin is often used in PhoneGap apps because it lets you query what kind of device the app is running on. Usually this is because you're interested in knowing if you're running on an iOS device or an Android device. As always, be sure to save your plugins. Now that we've added a plugin, let's see what the list looks like now. As you can see, it's listed in the list. The version selected was 1.1.3. Just like with platforms, we can determine what versions are available using npm. And the current version is indeed 1.1.3. If we wanted to see what versions were available, we can pluralize it. Removing a plugin is very similar to removing a platform. As always, we save the change. The same thing is happening in another directory for plugins as happened in the platforms directory. You can see that the currently installed plugins are listed under the plugins directory. Just as with platforms, do not make changes or add or remove directories in this directory. Let the CLI manage this for you. To this point, we've been using plugin IDs. However, this assumes access to the repository, and it assumes that the plugin version that you want is in the repository. Sometimes you'll need to install from Git, and if you're doing plugin development, you might even want to install from a local path. You can do both of those things. For example, the command to install the device plugin using Git looks like this. In this case, it installed the plugin from Git. This means we're getting the most recent version, and in fact, it's actually a development version. If we list the plugins, this is what we'll see. Notice that in this list, device is marked as version 1.1.4-dev. If you're testing a plugin to see if it fixes a bug, this is okay. Chances are pretty good, though, that you only want to use released plugins and not development plugins. However, some plugins are not released to the repository, or you might have a private plugin you wish to install, in which case using a Git URI that points to a Git repository is a good idea. What if we wanted to remove this freshly added plugin? To remove, you always specify the plugin's ID. This is true regardless of the source. I'm going to remove the device plugin again and install an older version. Updating, unfortunately, isn't quite as simple as the platform side. To update a plugin, we need to actually remove it and add it again. For example, in my case, I'm executing 2 commands on a single line. Minus the semicolon, you could run these 2 commands separately. Let's see what that did. And you'll notice now we're back to 1.1.3. At this point, you should have a pretty good handle on creating and managing PhoneGap projects and platforms and plugins. In the next video, we'll look at editing this project's configuration by editing config.xml. In the previous video, we discussed how you manage projects with the PhoneGap CLI. We talked about adding plugins and platforms. There are some things, however, that the CLI just does not do, and for these we need to edit config.xml. Config.xml is used to specify various configuration settings, but as you're about to find out, it also covers plugins and platforms as well. Let's get started. In this video, we're going to take a look at the purpose of config.xml, the location of config.xml, where you can find documentation about config.xml, and the typical settings that you use for config.xml. Usually these are starter settings. You'll modify them as your project goes along. Config.xml is actually used for a lot of things. It specifies your application's metadata, title, version, description. It specifies the initial page that should be loaded, pointing to index.html in our project. It stores plugins and platforms when using the --save switch on the CLI. It points to app icons and launch images. It stores configuration settings and plugin variables if needed. And it also controls the whitelist and app transport security settings. These are related to networking and what, if any, networking is allowed. Config.xml lives in your project's root directory. There's a lot of useful documentation when it comes to config.xml. You can navigate to the documentation using the link on the screen. This is what the documentation for config.xml looks like. There's quite a lot here, and I would urge you to read it for yourself. But let's go over some of the basics. The widget element is your config.xml file's root element. It describes the app ID and the version information. There are also additional platform-specific attributes as well. I mentioned metadata earlier, and this applies. The name, description, and author are all specified by the config.xml file. The initial page that is displayed when your app starts is controlled by the content element. Typically, this is just pointing at index.html. The access, allow navigation, and allow intent elements are related to the whitelist. The engine element indicates what platforms have been saved to our project. This is used when you use the --save switch with the CLI. And the plugin element does the same thing for plugins. The preference element allows you to set a value for a specific attribute. These are specific attributes that apply to one or more platforms and often controls what devices your app might be able to run on and how your app looks and feels. The platform tag is a little bit confusing. You might think that it indicates which platforms your app supports. Not quite. Instead, it's useful for restricting preferences and other settings to a specific platform. At the bottom is a very simple sample config.xml file. This simple config.xml file includes one plugin, the whitelist. It includes very permissive whitelist settings and includes some app metadata. Config.xml also stores the plugins that we use in our project. These are the typical plugins that I use to start with. You should add these using the CLI with --save. However, you can also edit config.xml and include these manually. The Crosswalk Web View and WK Web View bring modern web views to both Android and iOS. These offer improved performance as well as improved compatibility with modern JavaScript. The Device plugin lets us interrogate properties of the device, including which platform we're running on. Globalization allows us to query the user's globalization settings. For example, the user might be in Spain, and so we might want to know that so that we can render Spanish translations, for example. The Splash Screen plugin affords additional control over the initial launch image. If we don't include it, the launch image may disappear earlier than we expect. The Splash Screen plugin actually allows us to hold it on screen until our app is fully finished rendering, and then we can hide it nicely. The Status Bar plugin is mostly used for iOS. iOS prefers to overlay the status bar over your app's content. For native apps, this can be handled usually automatically. It's not so easy for PhoneGap apps. The Status Bar plugin lets us manage this a little bit better. As an additional benefit, the Status Bar plugin also lets us control the color of the status bar. The Whitelist plugin is installed automatically and is required. The Whitelist plugin controls networking access. And finally, this is a third-party plugin, Ionic Plugin Keyboard. This allows us to manage the keyboard mostly on iOS because we need to know when to avoid the keyboard on screen. Now I'm going to go ahead and add all of these plugins. Here's how. Before we do anything that might change our config.xml file, let me show you what it looks like after the steps of 7.2. The config.xml file, as you can see, is pretty simple. It looks a lot like the sample example from the documentation. A few things have changed, notably the ID and name, but the description and author need to be changed. The whitelist is present and very permissive, but there are a few new things. There's a platform tag for Android and for iOS, some preferences, and some new plugins. Now I'm going to add the plugins that I just talked about. Some of them have already been added for us because they were present in the template. So I'm only going to add the others. Now, you can add more than one plugin at a time. However, I'm going to only add this one on its own, and then I'll add the others. The problem is that sometimes variables get duplicated across plugins when you add more than one at once. Now I'll go ahead and finish up with the remainder. You may have noticed that I skipped WK WebView. This is because to work with our demonstration app, we actually need a variation of the plugin. There's a beta version that suffices for our needs. Let me add that now. Now that we've installed all these plugins, what does config.xml look like now? Let's look. At first, not much has changed, except content source has changed. This is a problem for Android, and we're going to have to correct it in a moment. Here are some new plugins. And in fact, this plugin comes with variables. This is the Crosswalk plugin. The WK WebView plugin also added a new preference. Now, in order to get this to work on Android again, we need to make a few changes. First, we're going to make use of the platform element to specify different content elements for each platform. For Android, we still want it to point to index.html. Now, we also need to change this port number. And we need to duplicate it in the preference here. Here are some typical preferences that I usually start out with in my projects. These aren't the end-all be-all of the settings that you'll use. Chances are good you'll modify, tweak, or add other settings as your project progresses. On the left-hand side are some elements that control the appearance of the app and how it functions. The first is background color. This is a 4-value hex string that indicates the color black. It is composed of alpha, red, green, and blue components. The next is disallow overscroll, and I always set this to true. This prevents apps from bouncing in iOS. I also set full screen to false so that Android maintains the status bar. Keyboard display requires user action applies only to iOS, but I also set it to false because we might need to show the keyboard programmatically if we focus an element, for example. On the right are some settings that control which devices the app can run on, as well as the orientations supported. For example, target device is currently set to universal, which means we support both phone and tablet form factors. Orientation is set to all for iOS orientation handling, and set to default for the typical Android handling. Android Min SDK version, here set to 19, limits the app to Android 4.4 devices and above. Notice that I've limited deployment target to 10. This prevents any iOS devices using iOS 9 or below from running the app. Normally, I wouldn't do that. I'd use iOS 9 instead because that's what Apple supports. Typically, Apple supports the current and the previous versions of iOS. In this case, however, I want to use more modern JavaScript, and iOS 9 doesn't support that. There are ways around that, but for now, it's easier just to restrict ourselves to iOS 10. Now, technically, I could list the Android Min SDK and deployment targets outside of platform tags. However, since they are platform specific, I'm going to go ahead and use the platform tags we've already created and put the preferences there. In fact, the template already comes with an Android Min SDK, but it's at the wrong version. So let's up that. The same is going to apply for the orientation preference. Now, before we go, we really do need to modify the rest of our app's metadata. In the next video, we're going to investigate the initial template that we created from section 7.2. Welcome to this final video of section 7. In the last video, we covered editing config.xml. We showed you the various preferences that you can set and how they control the app's look and feel. We also showed you how changes to plugins affects config.xml. In this video, we're going to be investigating the initial templates created by the PhoneGap CLI. In this video, we're going to look specifically at three templates. First, the blank template, then the Hello World template, which happens to be the default template, and then the Framework 7 template. This is the template we used in previous videos in this section. And then we'll look at the commonalities between all of them. First, let's take a look at the blank template. It contains just the absolute basics needed to get started, and the command you would use to create it is on screen. Notice the -- template and blank switch added to the command. I've opened up Finder on my Mac so that we can take a deep dive into what the blank template actually contains. And although the name implies that it's blank, it's really not. There's a lot going on here. Notice that there is, in fact, a config.xml file. If I show you the contents, it's very simple. There's a copyright file. There's a hooks directory, which we won't be using in any of the videos in this and other courses. There is a license file, a notice file. Next, there's a package.json file. This is something that all NPM modules, node modules, have, and so it comes by default with any of the templates. If we look inside, we can see that it's the blank template. Next, we have a platforms directory. Now, typically this would be empty. In order to capture a screenshot, however, I had to add at least one platform so I could run the app. In this case, the browser platform. Any platforms you add will live in this directory. So if I were to add iOS or Android or any other platform, they would show up here. The plugins directory comes empty initially because this template has no plugins. There's a README file included, and it just gives us a little bit of information about this template. And then we have the www or web directory. Inside is a single file named index.html. It's not completely empty, but it's pretty close. This is what the index.html file looks like. There's a very basic head section, a viewport meta tag, which is important to tell the device how to scale your app, the title, which is just blank app, and a lone script tag in the body. This is loading Cordova.js. There's nothing else going on in here. It's up to you to supply the rest. Next, let's take a look at the Hello World template. This is the default template that the CLI will use if you don't specify a template when you create an app project. But, as shown on screen, you can also specify this template directly. As you can see, it looks a lot like the blank template. So, the config.xml file is already much more populated. In fact, the Hello World app, intended as an example app to help you get started with PhoneGap, comes with a lot of plugins already defined, as well as a lot of icons and launch images. There's a new markdown document called contributing.md, which you could use if you wanted to improve the Hello World template and share the results with others. Like before, there's a copyright file, a hooks directory, a license file, a notice file, a package.json, just like the blank template had, and you'll notice that it's changed slightly to reflect the fact that it's using the Hello World template, a platforms directory, a plugins directory, which in this case has a lot of plugins already installed. This is because the config.xml file defines a lot of plugins. Like the blank template, there's also a README document here. It happens to have a little bit more information about the template. And there's a web directory. Now, the blank template had only one file, index.html. This one has a lot more files present. This is what the index.html file looks like. There's a lot more going on here compared to the blank template. There's a lot of information in the head. What I want to point out is the style sheet link. The style sheet points to CSS files that control the look and feel of your app. Next comes the body section, and here we have some HTML elements, divs, H1s, and paragraphs. We also have some script tags. One points to Cordova.js, and another points to the js/index.js file. I'm going to show that file to you in a moment. but the takeaway here is that it is where your app's logic lives. And then finally, we have the Bootstrap section. This kickstarts the app. On screen, you should be seeing what the app would actually look like if you were running it on a device. The text, PhoneGap, and Device is Ready are evident in our HTML. The look of the app comes from the CSS file. As you can see, there's quite a bit going on in this style sheet. There's a gradient for the background. This displays our app's logo that you can see in the screenshot. And there's various styling for, say, the header, which is PhoneGap, and some stuff defining animations. Now, I also mentioned the index.js file. Let's look at that. Again, the blank template didn't have any of this. In this section, we're defining an object called app. If you recall, the index.html file called app_initialize, and this is the function it's calling. It calls bind events, which is defined here. It adds an event listener for the device ready event. When this event has been received, it calls onDeviceReady. This function then calls another function called receivedEvent. What it does isn't terribly important, just that this is where the app actually starts doing things. Now, there's no requirement that your JavaScript be structured in this manner. This is just the manner that the PhoneGap team have used when creating the Hello World app. There are some other files in here of note. There's an icon.png file. This serves as the app's icon. There's a file in the image directory. This is what's displaying in the screenshot. There's a res or resource directory as well. This includes icons and launch images for all the supported platforms. So if I navigate to, say, iOS, I can show you the app icon for iOS. I can also show you the launch image. There's also a spec directory. This directory is largely concerned with testing. If we look at the index.js file in here, you'll notice that it's describing tests and the results. The spec.html file, as you might guess, interacts with the index.js file here. Technically, you could eliminate both of these files and your app wouldn't notice the difference. This is the template that we used in section 7.2 and 7.3 and will continue to use for the remainder of this course. As before, a lot of this looks very similar. The only file that looks slightly out of place is this jsconfig.json file. You can safely ignore it. It's just something that was created by my text editor. There's a config.xml file, and it should look familiar to you since this is what we edited in the previous section. There's a copyright file, a hooks folder, a license, package.json, a platforms directory, plugins, and you'll notice that these are the plugins we added in the previous video, a README, and a web directory. Now this web directory looks very different from the Hello World template. There's two HTML files, an about file and an index file. This is what the index file looks like. It's already different from the Hello World file. There's some similarities in the head, but there's also some additional style sheets. Notice that these are pointing to a lib directory and a Framework 7 directory. This is used by Framework 7 to provide the app's look and feel. But we can specify our own styles as well. The body section is very different. And I'm not going to go over what all of this does in this video, but I just wanted to point it out. There's a lot of elements here that form the structure of a Framework 7 app. At the bottom is a script tag that includes Cordova.js, which again is always required, and a script that points to Framework 7. Finally, there's a script that points to myapp.js. This is where our app logic will live. About.html doesn't look like a typical HTML page because it's missing the head and HTML sections. Consider it to be a fragment. All it needs to include is the information to display the About page, because it will be inserted dynamically into our application's document model. Now, index.html was loading myapp.js. There's quite a bit here going on, and what should now be clear is that PhoneGap does not impose any specific structure regarding your JavaScript, HTML, or CSS files. Having mentioned CSS, let's also take a look at the styles. There's not a lot going on. In fact, this sets the status bar to black, which you can see on the screenshot. There's a lib directory here as well. This is the Framework 7 framework. Depending on what framework you might use, these files would obviously be very different. So what have we learned? There's a lot of commonalities between these, even though each template is very different. 1. The config.xml file is always in the same location, the project root. All of them have a www or web directory, and within that there's always an index.html file. However, they also all allow a lot of freedom with regard to how we structure our HTML, CSS, and JavaScript. In this section, we've covered a lot. We've installed and explored the PhoneGap and Cordova CLIs. We've discussed project management, including how to create a project and how to manage platforms and plugins within a project. We've discussed and edited config.xml, and we've investigated some of the initial template structures. In the next section, we're going to test our install. Welcome to Section 8. In this section, we're going to test our install. We're going to test the app that we created in Sections 7.2 and 7.3 in the last section. In this section, we're going to take a look at the following. We're going to run our app on an iOS device, and we're going to run our app on an Android device. In this video, we're going to run the app that we created in 7.2 and 7.3 on iOS. In this video, we're going to look at the following. We'll show you the CLI command that you can use to run on an iOS device, what the app looks like on an iOS device, and some troubleshooting tips in case you run into problems. To get our app running on an iOS device, first you need to attach the device via a lightning cable to your computer. Your device may prompt you to trust your computer. If it does, answer yes. Next, you can type PhoneGap run iOS -- device. Usually -- device isn't needed because PhoneGap will detect that there's a device attached, but it's better to be absolutely sure, so I always use the -- device switch. And then wait for the app to start. So what does that look like? First, I've already attached my device. Next, I can type in PhoneGap run iOS -- device. And you can see there's my app. I can interact with it. At this point, we know that our installation of PhoneGap, Xcode, and all the other utilities necessary for development are installed and working correctly. What happens if you run into some problems? First, make sure that PhoneGap is up to date. Then, verify that all your plugins and the Cordova iOS platform are also up to date. Sometimes, when these are out of date, they can cause problems when building your app. Verify that you've installed the most recent version of Xcode that is supported by PhoneGap, that the command line tools are installed, and that the license has been accepted. You can install the command line tools by typing xcode-select -- install. You can accept the license by typing sudo xcode build - license. Sometimes it also helps to remove the Cordova iOS platform and add it back again. Use this as a last resort, but sometimes when it's being really stubborn, this has worked for me. In the next video, we're going to go over running the same app on Android. Welcome to the second video in Section 8. In this video, we're going to run our app on Android. In the previous video, we ran our app on iOS. The process is not terribly different. In this video, we're going to look at the following: the CLI command to run our app on an Android phone, what our app looks like on an Android device, and we'll go over some troubleshooting tips. To start our app on an Android device, you first need to attach your device via the USB cable. Then verify that ADB can see it by typing ADB devices. If it can see it, then you're ready to run the app by typing PhoneGap run Android -- device, and then you can wait for the app to start on the device. First, let's verify that my computer can see the attached device. Now, it's possible you could have several devices attached at once, but usually I limit that to one at a time. Notice that ADB does indeed see my device. Now, I can run my app on Android. This is the app running on my Android device. Now, as you can see, it looks an awful lot like an iOS app. Don't worry, we're going to change this in the sections going forward, but it does prove that our installation is configured correctly and all the tools are properly installed. So, what if you run into problems? Well, like with iOS, make sure that PhoneGap, all your plugins, and the Cordova Android platforms are up to date. You should also verify that the Android SDK is up to date and available in your path. You can check your path by typing echo $path. You should see two items that point to the Android SDK and to the Tools and Platform-Tools directory. You can verify that your Android SDK is up to date by typing Android at the command prompt. As with iOS, sometimes it can be beneficial to remove the platform and add it back again. You should only use this in the most extreme of situations, but when something is being particularly troublesome, I have found it to work in some cases. In this section, we have run our app on an iOS device, and we have run our app on an Android device. We've also mentioned some common troubleshooting tips. In the next section, we're going to cover what a framework is. See you then! Welcome to Section 9, What is a Framework? In the previous section, we verified that we had everything configured correctly and we were able to launch our app on an actual device. In this section, we're going to start getting into the nitty-gritty of developing an app. To start with, we need to decide how we're going to architect our application. So in this section, we're going to take a look at the following: what a framework is and why you should use one, some well-known and well-supported frameworks from which you can choose, and the framework that we'll be using for this course. The reason we're talking about frameworks now is simply because your app is architected around the framework you choose. Therefore, we need to choose a framework before we start writing a lot of code. Welcome to this video entitled What is a Framework? In this video, we're going to look at the following. We're going to define what a framework is. We're going to go over the benefits of using a framework. And just to be even-handed, we're going to go over the downsides that you might want to be aware of when choosing a framework. So, what does the word framework mean? When it comes to JavaScript and hybrid applications, there is no universally accepted definition. This leaves it open to interpretation, and often you'll find different people with different definitions. However, frameworks often provide the infrastructure upon which your app is built. They often provide convenience methods that you can use to manage your app's components and state. And they usually provide widgets that you can use to build your app's user interface. These would include buttons, list items, icons, and those kinds of things. Some frameworks only specialize in one or two of the above, in which case you will often find yourself using one or two frameworks as needed. This can often factor into your decision making. Do you want to learn two frameworks or one? So there are a lot of different types of frameworks, and for each area of mobile hybrid application development, there are corresponding types. There are JavaScript frameworks, and these usually bring about enhancements to the standard library, document object model manipulation, model view controller or other paradigms, event handling, and some view management. Other frameworks are for HTML and CSS. These provide user interface widgets and manage their appearance and animations. Now, view management at the bottom of this slide goes across all three areas. This is because the framework that manages your views needs to be able to manage the JavaScript, the HTML elements, and the styles that go along with that. So there's a lot of frameworks out there. We're not going to go over them in this video, but I just wanted to show you a quick example of how these kind of fit into the scheme. You can see that very few of the popular frameworks supply every piece. However, there are a few noticeable exceptions once you understand that there may be the same company behind both products. So for example, Framework 7 supplies the HTML and CSS side, which means that they are supplying user interface elements. But the same people that make Framework 7 make DOM 7, and Framework 7 utilizes DOM 7. The stack as a whole is essentially one piece. This is also true of Sencha Touch, which uses EXT.js as its underlying JavaScript framework. Other frameworks let you mix and match. For example, Ionic and Onsen UI can work with a variety of JavaScript frameworks. Apps consist of views, models, routes between those views, event listeners, and lots of actions that operate on data. Building them all by hand is time-consuming and often error-prone. And let's face it, it usually involves a lot of boilerplate. This is repetitive code that is the same or very nearly the same for similar components and situations. Frameworks abstract a lot of this stuff away, which means that there's less for you to worry about. When using vanilla JavaScript, you may find yourself writing similar patterns over and over again. JavaScript frameworks will often provide similar and often better supported methods you could use instead. A simple example is document.getElementById, which we can use to look up an element in the document object model. However, it's often easier to type the $sign used by jQuery and a lot of other frameworks. Plus, this $sign actually provides additional functionality. It can search for classes and other selectors. HTML and CSS frameworks will supply the basic user interface widgets. These could be buttons, icons, panels, dialogues, alerts, and the list goes on. This means that you don't have to build the infrastructure for creating these elements, and you don't have to build the corresponding and frankly often confusing and quirky CSS rules from scratch either. So, what are the benefits of using a framework? You've already heard some already. In short though, faster development. The less code that you have to build and test, the faster you can build your app. If you have to build your framework first, then it takes longer for you to build your app. Support is also often big. Most popular frameworks are very well supported by companies and large communities alike. The pool of available expertise should also be considered. Popular frameworks will typically have large expert pools should you need assistance. Device support is critically important. Popular frameworks are tested against a wide variety of devices, and you'll probably never ever have access to this entire pool of devices yourself, unless you want to spend a lot of money. And last but not least, if you don't use a framework, you'll inevitably end up writing one yourself. For some people, that's a good thing because they're trying to figure out how a framework works. But if you're trying to build an app, there's usually no need to reinvent the wheel. So, what are the downsides to using a framework? Well, all frameworks are opinionated to some degree. Some frameworks have fewer opinions than other frameworks do. Depending on your coding style and your temperament, you might want to look at various frameworks because some may not suit you. You will definitely want to look at code samples to determine whether or not they match your style. Frameworks can often be opaque and appear as magic. And generally, I dislike magic code, simply because it's difficult to know what's going on at the deepest levels when something goes wrong. As such, you should look for frameworks with excellent debugging tools. Adding a framework adds an additional dependency to your app. The more dependencies you have, the harder they can be to maintain. Of course, you have to weigh this against the benefits of that additional dependency. And of course, there's more to learn and keep up with. This could be a good thing or a bad thing, depending upon your temperament. If you like learning, this is great. If you like stability and don't like a lot of change, then this could be a downside, because as the framework changes, you will need to keep up with it, not just JavaScript, HTML, and CSS. In our next video, we're going to go over how we choose a framework. We'll look at some of the common frameworks and some of the things that go into our decision making. Welcome to the second video in Section 9, Choosing a Framework. In the previous video, we talked about what a framework was and why you should probably choose one for your app. In this video, we're going to look at the following: how to select a good framework, and we'll point you towards some of the popular visual frameworks out there. So what are some qualities that you should consider when choosing a framework? First and foremost, documentation is incredibly important. Look at how easy it is to get started. Make sure that the documentation is concise and understandable, with lots of examples. The more examples you have, to me, the better. I tend to be a visual learner when it comes to code. Check out any available galleries and showcases. Showcases can be great because they can show you who is using the framework. Kitchen sink apps are also useful because you can run these on your device to verify performance. Also, look for available support options, including community forums. The forums are a great place to check activity and morale. You might also want to consider paid support options. The Ionic framework is a very popular framework these days. The current version is 1.3, with 2.0 coming out shortly. In fact, it might already be out by the time you watch this video. It supports the Angular 2 JavaScript framework. If you recall from the previous video, a JavaScript framework provides a standard library of sorts for creating views and managing them. However, the visual appearance in this case would be managed by Ionic. Some pros. Ionic has modern design themes that look great on iOS and Android. It has a marketplace where apps and components can be shared, a rapid prototyping utility, and a cloud backend available. Plus, there are lots of great apps in the showcase. Onsen UI is another very popular framework. They just recently released version 2. It supports a lot of JavaScript frameworks, making it one of the most flexible of the popular frameworks. It supports Angular, Angular 2, React, Vue.js, and more. This means you aren't beholden to a specific framework if you like this visual framework. It supports a theme roller, which makes it easy to design your own user interface, and it has iOS and Android themes that mimic the native device's themes. Kendo UI has been around for a little while. It's also on version 2. It supports jQuery and Angular 2. It has modern themes that look at home, again, on iOS and Android. It's also a commercial offering. Now, at first this might sound like a con for those of us who might be more budgetarily inclined. However, this can also be a great benefit when it comes to enterprise-level support. If you're building a large app that needs a lot of support, this is a good reason to consider Kendo UI. Sencha Touch is another framework that's been around for quite some time. It's also a commercial offering, which again means great enterprise-level support. It supports the EXT.js framework. It has themes that look at home on iOS and Android, but also has a lot of other themes that would work on various other devices. Framework 7 made a big splash when it was first released. It was one of the first frameworks to support the swipe to go back gesture that iOS has made popular. And it did it really well. It was hard to tell it from native. Framework 7 is also very performant. It supports the DOM7 and Tiplet7 frameworks. Framework 7's iOS and Android themes are very close to native look and feel, and most people would probably have difficulty distinguishing the two. It's also very approachable, especially if you're familiar with jQuery. In this video, we introduced you very quickly to some of the most popular visual frameworks out there. Which one you choose is largely subjective based upon the quantitative measures we listed earlier. If you prefer a certain community, coding style, or just the look and feel, that might steer you one direction or the other. In the next video, we're going to unveil our chosen framework for this course. Welcome to this final video in Section 9. In this video, we're going to take a look at Framework 7. The previous video, as you may remember, we covered various frameworks and why you might decide to pick those. In the end, however, Framework 7 made the most sense for this type of course. In this video, we're going to take a look at Framework 7, at the documentation, the kitchen sink, the various layouts that are available. So on screen, I have the Framework 7 website. As you can see on the right, there is already a kitchen sink example present. I want to look at the kitchen sink example to show you a little bit more of what Framework 7 does. So first, as you can see, it has a very iOS 7 design, but it also provides a very material design, if necessary, for Android. Now, we could technically use the material design on both iOS and Android. A lot of Google's own apps use material design on iOS. However, when possible, I would prefer to look as close to native as possible. Our app is intended to store short notes. This means we're going to need a component like a list. Let's look at some of the list options that Framework 7 offers. In fact, you can already see them because this is a list of the available components. Let's look at a media list. So, as you can see, we have quite a bit of flexibility here. We should have no problem building a very nice list for our app. We also want to include some swiping options, so let's take a look at their swipe to delete. This is nice. They support multiple actions instead of just one. We also need some form support since our app will need to accept text. So let's look at the form elements. This is quite nice, and they include a text area. I think we should be able to accomplish whatever we need here. So let's look at how those look on material as well. Here's the media lists, and these look just fine. Swipe to delete, and these look very similar to the iOS versions. And form controls. Given all this, I think we'll have no problem building our app using Framework 7. Now, the visual appearance isn't the only thing. The documentation also needs to be well laid out and understandable. So let's take a look at the documentation. Right up front, it indicates that we could read the Getting Started guide, which is nice. They also supply a basic app layout, which, as far as I can see here, makes a lot of sense. There's no surprises here. They tell you how to initialize an app, how to add another page, and how you can write code to react to changes in the app. Now, one thing that's important is that the iOS app layout and the Android or Material app layout are different. There is, however, a way to merge these into a single app so that you don't have to duplicate a lot of code. That is available using a tutorial. They start with the iOS layout as the base and then add on the Android portions. And it's not too hard, and this is in fact how we will use Framework 7 in our apps. Let's look at some of their demo apps. Let's look at the To-Do 7 app. We'll add a task, add another, check one off, and we can even delete one if we so please. Should we ever need help for Framework 7, the best place to go is their forum. As you can see, there is a bit of activity in their forums. If we have a specific question, of course, we would search for what we were looking for. In this section, we covered the following: what a framework is, and why you might want to use it in your apps, and in fact, why we're using one in our app. We showed you some example frameworks out there, visual frameworks like Ionic. In the end, however, we chose Framework 7, mainly because it's very approachable if you already know things like jQuery. In the next section, we're going to cover designing our app. Welcome to this first video. In this section, we're going to design Filer, the app for this project. First, we're going to design it visually. So user interface, look and feel, that kind of stuff. Then we'll define the underlying data models. Now the app itself is not terribly complex, especially right now. But as you progress through future courses, we're going to be adding a lot more functionality to it. So we need to make sure that the app is modular. With all this said, let's get started. In this video, we're going to cover the user interface design. We're going to cover all the views that we need to have present in our app. We're also going to detail the interactions between those views. To start with, I always find it good to mock out the user interface. And so that's what I'm going to start doing. The tool I'm using here is called Concepts, but any drawing tool or even a napkin will do the trick. So first I'm going to draw the initial view. Now this is just a sketch, so I am not going to be too particular. Okay, now we know we're going to need a list of notes. So that calls to mind that we'll be using a list. But I want the list to be a little bit more than just a simple static list. I want it to have at least a part of the note and maybe an image if we were to add images later on. Now, I'm initially designing from an iOS perspective, so this would be a little chevron. Now, we need a way for the user to add a note. So, to me, the most obvious thing from an iOS perspective would be to add a button on the navigation bar. It also wouldn't hurt to have a button just to explain the purpose of the app. Okay, we also need a way to delete a note. On iOS, you would typically use a swipe to delete, so I'm going to make a note of that. We might also want other actions, so perhaps later on, sharing, or even duplicating. So we have the main form. Let's add the next one. So if the user taps on a note, we want the note title, we want a back button, and the idea behind this app is that the user can have many items within a single note. So that implies another list, but I don't want it to be obviously list-like. So instead of lines separating each item, we won't actually have those. However, we do need them to be able to move around. So we're going to have little things over here. These are the handles to move items around. Now, we will probably also want to have a date on here. We could also do items that perhaps were checkboxes or to-do lists. These also need swipe to delete. But as a whole, we also need some way of deleting this note. My poor rendition of a trash can. And we need an easy way to add a new entry. Down the road, ideally, we'll have multiple different kinds of types of entries. So we might have text only, to do, audio, movies, a map. So these buttons would be at the bottom and would allow the user to add new items. Now, if they if they tap the trash can, we should make sure that they are sure. And if they tap an existing item, they will be taken to to the editor. Now, the editor is going to be specific to the type of item. So a text item will be different than, say, an image item. We'll also give the option to delete it with back. This is a text area. So I'm going to put the keyboard here. Now, I'm not going to put save or anything on here because the assumption is everything saves automatically. So this is a good example of what things might look like from an iPhone perspective. What about from, say, a tablet? Not a lot would change. Of course, the form factor does. So I'm going to build this out as a split view. And then if they tap something, they would have the note here. And notice material design here would be pretty similar, although instead of centering, say, note here, it would be moved to the left, for example. And there we go. Now we could take this as well and make a high fidelity mockup. And by the magic of editing, here are some legible mockups. I've done these in a tool called OmniGraffle, but any diagramming tool will do just fine, including Photoshop. This view maintains largely what we had before. The application title is at the top. There's a button to add notes. The notes themselves are full of information, and there's a swipe to delete action. This is the note view. This is what appears when the user taps a note. As you can see, each note has several pieces. Each piece could technically be a different type. We have the swipe to delete action here as well. We have an edit button at the top that when tapped allows the user to move things up and down. We also have an add item icon in the lower right corner. When tapped, this will display a list of the possible piece types that the user could add to their note. This is the piece editor, and it allows the user to edit a specific part of a note. There is a delete button in the upper right that allows them to delete the specific piece, and they can enter the text in the middle. If this were a different type of piece, say an image, if we were to add one later on, this might be, say, an image editor. In this video, we covered the look and feel of Filer. In the next video, we're going to cover the underlying data structures. Welcome to this last video in section 10. In this video, we're going to be designing our app's models, or data structures. The design from the previous video will educate our direction with regard to these models. In this video, we're going to take a look at the following. We're going to look at the various models that make up our app. These include notes, note, and piece models. We're also going to look at the persistence layer. Now, initially, this layer is going to be very simple, but we're going to build it so that we can expand upon it in later courses. This is our entity model. It's going to serve as the base for just about everything that can be stored or persisted in our app. It extends the emitter class, which means this object can send events and other objects can subscribe to listen to those events. Each entity will have a link to the various store. A store is where data can be persisted. Each entity will have a unique identifier, and there will be some private methods that handle creation, merging of data, and serialization. Serialization in this context means JSON.stringify and JSON.parse. Each object has a constructor, and each object knows how to save and load. Save and load talk specifically to the store. There's also a declassify method in here, and it's just a little method that strips out the functions and everything else on an object to give us an object that is easier to serialize. I wanted to call your attention to the asterisks in front of save and load real quickly. This indicates that these methods are asynchronous. They will return a promise And a promise is just a promise to return data. Technically, the storage mechanism we'll be using in this initial version of the app is synchronous in nature, but future versions of this app will use asynchronous storage mechanisms, and so we need to return a promise instead of the actual data. It's easier to architect the app asynchronously from the start rather than try to make patches to it later. This is our note entity. Notice that it extends entity. It includes content. This content is an array of notes. The rest of it looks fairly similar. These methods, however, need to know how to save and load an array of notes. This is our note. It extends entity, so it inherits the behavior of our entity class. We give a note a title, and we give it an array of pieces. This is the content of the note. We've also given it some extra properties, including color and some date tracking, such as when it was created and when it was modified. Again, save and load need to be overridden so that they know how to save and load a note instead of, say, a collection of notes. This is our piece entity. It represents a piece or part of a note. In the future, we might have multiple kinds of pieces, so we include a type property so that we know what type we might be loading or saving. We also include a title for each piece and the content, in which case this is a string. Other types of pieces might have different kind of content. We also include color and date created and modified. Now, in this case, the piece is pretty simple, so the save and load methods from entity suffice to save and load our piece to the data store. Now, piece is rather generic. You could have many different kinds of pieces. So let's get specific. For now, our app is going to handle text pieces. Now, technically, there's really nothing special that a text piece has to do versus a generic piece. But in the future, it will become important to differentiate the kinds of pieces. Now, for now, we're going to use local storage. Local storage is far from ideal. It's not guaranteed to be persistent on mobile devices, but it will serve us for now. In the future, though, we want to use other storage mechanisms, such as IndexedDB. These other storage mechanisms are usually asynchronous in nature, so we're going to build our store to be asynchronous, even though local storage is synchronous. Hence the asterisks next to save and load. Now, the store is really simple. It's essentially an object store. Every object has a unique identifier and the data associated with it. The store is responsible for pushing that data into and out of the storage adapter. In the future, we will have many different kinds of storage adapters, and we can use whichever one is most appropriate for the situation. For reference, this is all the models on one screen. Right now, our app is fairly simple, but as we add various kinds of pieces and other storage adapters, it will grow in complexity. It's always a good idea to make sure that you have a well-formed data model before you start writing a whole lot of code. Otherwise, you'll find yourself having to come back and rip out pieces from earlier iterations when you find out that for some reason your model didn't quite capture everything you needed it to do. In this section, we covered the filer user interface and the interactions between the various views. We also discussed the data structures, or models, and how they interact. Now that we've designed the user interface, the user interactions, and the data model, we're ready to start writing some code. I know, it's taken a long time to get here, but it's always important to start out a project correctly with a good foundation. Welcome to Section 11, Scaffolding Filer. In the previous section, we designed the user interface and data models for our app called Filer. In this section, we're going to look at the following. We're going to discuss some important terms, the project folder structure, which is different from the Cordova structure, how to support iOS and Android material design themes at the same time, and how to handle some additional image assets that our app will need. Welcome to the first video of Section 11, Folder Structure and Terms. In this first video of Section 11, we're going to discuss the project's folder structure and some important terms. Let's go over some important terms. First, I need to define what an emitter is. An emitter is an object that emits events whenever something happens. Other objects, or interested parties, can subscribe to those events so that they can be notified when the trigger occurs. This can be used to build what's considered an observable, an object that emits change events whenever the object's data changes. So in this short example at the bottom, we create the emitter, and then we subscribe a method to the boo event. Then we tell the emitter to emit boo, and in this case we pass some data along as well. When this event is emitted, the console will log, "You scared the life out of me." When we no longer need to listen to the event, we also need to unsubscribe from it. Next, I need to make sure that you understand the concept of a store. A store is simply a data container. Stores are typically, but not necessarily, persistent, and stores manage the data retrieval and storage, often using adapters for various storage types. So in the first line of the example below, we create the store using a local storage adapter. This uses the browser's local storage API as the storage mechanism. Then we create a unique identifier. We subscribe to the saved entity event so that we can be notified when something is saved to the store. We then save an object to the store with the unique identifier. After that completes, it will log saved data to store to the console. We then try to reload that data from the store, and that's logged to the console when that completes. If you're not familiar with promises, that's what we're using in this section of code with the .then. A promise is the promise of a result. Promises are used in this case because storage adapters tend to be asynchronous, and so we don't know when the value will be returned to us. Instead of blocking the entire app, we can just wait until the data is available. But to do that, we need to use .then. A model is just largely a representation of a data structure. It usually also has some methods that make it easier to work with that data structure. For example, a note might contain a title property and a text property, and these are all specific to the type of data that we're using. Models generally don't generate their own representations. These are called views. Instead, separate code uses the model to generate the view, and this is considered to be a separation of concerns. In the example below, simple model is a very simple model. It only has two properties, a unique ID and a text field. Models will tend to be pretty simple, although some of the methods for working with the models may be a little bit more complex. For example, you might have additional methods that formatted the text a certain way or returned a prettier date format. You might also have methods that work with models within this model. For example, if this model were a collection of other models, you might need methods to add, remove models from that collection. A factory is a really simple pattern. Its intent is simply to create an instance of a class. Typically, you'll use factories a lot when you need to create a different kind of instance based on certain factors, say a text note versus an image note. And that's exactly what we're doing in the example below. Depending on the incoming type, we return two different kinds of notes. If we don't know how to create the note, we then throw an error. Let's go over some Framework 7 terms. First, let's go over view. Framework 7 co-opts this word and applies a slightly different meaning to it than the typical terminology. We would typically say a view is a representation of a model, for example, what a note looks like. In Framework 7's case, however, a view is really an area of the screen that handles its own navigation. An app needs to have at least one, but it can have more than one visible on screen at once. Think a split view controller for an iPad. A page is also a Framework 7 term. It indicates a specific page or location in the app. Essentially, it's a page on a website. A template is essentially a reusable mold that can be used to stamp out instances based on a given context. Templates will typically render dynamic data from corresponding models. A simple example might be a list item that displays a picture and some text. This can then repeat for however many list items there are in the model. A helper is a custom extension to the templating language used by Framework 7. Essentially, it calls a JavaScript method which then inserts the return result at the specific location in the template. So here we've got a simple example called render_piece. It uses the current context type to determine which kind of piece to return. Later we can use it in a template like so. A partial is a special class of template. Essentially, it's a reusable template that can accept some additional parameters and can be called from other templates or other partials. So to call a partial, we just use the greater than sign after the two curly brackets. We can pass additional parameters using parameter equal value format. Next, let's look at the structure for our project. Now, this is referring to the structure within the www or web directory of a Cordova app. So it's not the Cordova app structure, it's just the structure of our HTML, CSS, and JavaScript. I like to categorize my JavaScript, HTML, and CSS quite a bit, so I tend to use a lot of folders. So let's get started. Our app's custom styles will live in the CSS directory. Other than index.html, our app's other HTML content lives in HTML. Inside there are three directories: Pages, Partials, and Templates. Pages refers to actual pages, so for example the notes list, note, or an editor, for example. Partials refer to some of the reusable templates like navbars. And templates refer to reusable templates that we call from JavaScript code. Additional images that our app needs are placed in the img directory. Our application's JavaScript code lives in the JavaScript directory, or JS. There are several folders here as well. To avoid magic values as much as possible, I like to use a constants folder. If I need to use an error code, instead of returning, say, code 5, I can use a constant instead. That makes it easier to read the code. Factories includes routines that create instances of objects. Helpers include the routines that we can call from templates, as described before. Lib includes various utility libraries, classes. In this case, you can see that it includes emitter and entity. Our app's data structures lives within models. And the code that supports the visual representation of our app's pages lives in the Pages subdirectory of the JS directory. Code for handling data persistence lives in the Store directory, and various storage mechanism adapters live in the Adapters directory. The mocks folder is just used for testing, say from Node instead of a browser. The outer library directory, or lib, includes third-party frameworks, such as Framework 7. Now, you could create this structure yourself, manually, but the easy way is simply to download the code package for this video, which is available at the link on screen. In the next video, we're going to discuss how to support iOS and Android themes within the same app. Welcome to the second video in Section 11, Supporting Android and iOS Themes. In this video, we're going to look at the following: why we would want to support multiple themes in the first place, how Framework 7 suggests handling multiple themes, and how we're going to do it in our app. So why do we want to support multiple themes? Personally, when possible, I think it's wise to fit in with the platform on which your app is running. So to me, this means looking like an iOS app when you're running on iOS, and looking like an Android app when you're running on Android. There are some options then that you can use to accomplish this. You could make a separate app for iOS and Android, or you could have theme-specific templates and pages, but this means duplicating those templates and pages for each theme. Or you could use generic templates and pages with some sprinkles of theme-specific code, which has less duplication and less boilerplate. Framework 7's suggested method is detailed at the website on the screen. Essentially, they use the iOS theme as the base. They then include theme-specific CSS at startup, in this case determining if you're running on iOS or Android and then choosing the specific CSS. Then, on app start, they move a few elements around in order to support Android. And then, on each page, navigation bars specific to iOS and Android are supplied. Here's an example of what a very simple page would look like using Framework 7's suggested method. At the top, there is the iOS navigation bar. Then, at the bottom is the page itself. This is because the iOS navigation bar needs to live outside the page. But directly inside the page is another navigation bar, and this is for Android. The page content is actually at the bottom portion of the screen. Now, notice that the iOS and Android navigation bars are very similar, although not quite identical. It would be nice if we didn't have to duplicate these navigation bars on every single page we build. This is what the iOS baseline looks like. Now, it's very similar to what we've already got in our Framework 7 app after we created it using the PhoneGap template. So we don't really have to worry about changing this a whole lot, although there are some changes that we do need to make. This section of code actually applies the specific theme to the app. So you'll notice that if we're running on an Android device, we append Material Design CSS files. Otherwise, we append iOS files. We do have to have some JavaScript present in order to determine whether or not we are using iOS and Android, and to tweak the document object model slightly if we're running on Android. Framework 7 provides two properties for this, prototype.deviceAndroid and prototype.deviceIOS. We can then store the value of these properties in Template 7's global area. This lets us use them in templates. Then, if we're running on Android, we change the class of the navigation bar and move it around a little bit. Next, we have to initialize the app. When we're doing so, we need to let Framework 7 know if it's going to be using a material design or not. Hence, is Android in this line of code. We also have to enable Template 7 pages. This uses Framework 7's template engine to render our pages. So how will our app do it differently? Well, to start with, we're actually going to use Framework 7's suggestion. We'll start with iOS theme as the base, include theme-specific styles at startup. We'll move a few elements around to support Android, and each page will have navigation bars. But we don't need to stop there, because we don't need to duplicate those navigation bars on every page. Instead, we're going to extract the navigation bar boilerplate into partials, so that there will be an iOS and Android-specific navigation bar. This lets us avoid duplicating a lot of code on each of our app's pages. So what do these partials look like? On the left is the iOS navigation bar, and on the right is the Android navigation bar. Notice that the structure is very similar. There's only a few differences. I've highlighted those in bold and struck out those that disappear. You could take this even further and make partials for just about every bit of duplication. I'll leave that as an exercise to the viewer. So what does a page look like when using our partials? It's pretty short, in fact, 9 lines long. And this is precisely because we aren't having to repeat the internal content of the navigation bar twice. However, navigation bars do change on various pages. So in order to accommodate that, we've had to add support for additional parameters on the partial. So let's start with what our app's code actually looks like in an editor. So I'm currently in index.html. Most of this initial content is the same content that we got when we created the app. However, I've removed all of our app's custom styles. We're going to inject those later. I've also removed all of the pages that were present in index.html because our pages are going to be added as needed later. Now let's go to app.js. You can see that we've used some of the same code from the tutorial on Framework 7's website. Here we are determining whether or not we're running on Android or iOS, and we're setting those values into Template 7's global area. In this section of code, we're loading the CSS style sheets dynamically, and we're using Material if it's an Android device, and an iOS theme if it's an iOS device. We're also appending our app-specific style sheets. Then we create our app, telling it if we're using the Material theme and that we're using Template 7 pages. And a little bit below, we are changing the class on the navigation bar. And in a key difference from Framework 7, we're actually removing the navigation bar from the DOM. This is because we provide the navigation bar with every page. And if we don't do this remove, we actually end up with two navigation bars on screen at once. The partials themselves look like this. Here's the iOS partial. It has a couple extra features than the one in the slide, but you're not missing much from the slide version. Essentially, we have support for left icons and right icons. And the Android partial. Using it is incredibly simple. Let's look at the Notes page. Here's the iOS navigation bar and the Android navigation bar. Now you may wonder where, say, the page title has gone. That's because we're going to be providing the page title from JavaScript. So if I take a quick look there, this context object is what we're going to be passing to that template. And it's going to have the page title of Filer. Now we'll get into how these pages are built in a later section. I just wanted to show you how everything works together to provide an iOS-specific theme and an Android-specific theme. In the next video, we're going to discuss some additional image assets that our app will need and how to use them. This is the last video in section 11. In this video, we're going to be discussing additional image assets. So in the previous video, we've discussed how to support iOS and Android themes. In this video, however, we're going to look at the need for additional image assets, a little bit of the differences between SVG and PNG graphics, some image sources from where you can obtain images, and svginjector.js, a support library. So why do we need additional images in the first place? Well, every app has application-specific needs. Framework 7 and other frameworks typically provide some useful icons like the back button, chevrons, list icons, and such, but almost certainly you'll need additional icons. Our app does for sure. Add and delete icons, note type icons, to name a few. When we're talking about icons, typically you'll find an icon in one of two formats: SVG, or Scalable Vector Graphics, or PNG, Portable Network Graphics. SVGs can be resized without loss of fidelity. They can also be recolored. However, it is slower to draw an SVG than a PNG. PNGs are quick to draw, but they can't be resized without loss of fidelity, and they can't easily be recolored. Both support transparencies, so that's not an issue. And either way you go, it's preferred to use sprite sheets instead of loading each image individually. If you're displaying photos, JPEGs are of course preferred, but otherwise use either SVG or PNG. So where does one obtain SVG images suitable for use in applications? Well, there are a few that I like. OpenIconic is excellent, as are Evil Icons and Smart Icons. However, for this project I used IcoMoon. It easily lets us select some desired icon from various sets, and it exports them as SVG. We can then use the SVG file in our app to render all the SVG icons in that set. When using an SVG sprite sheet, each sheet will include lots of icons, and they're each given a name. To display them, we use two tags: the SVG tag with a view box that specifies, give or take, the dimensions of the icon, and the use tag, which indicates what symbol name to use. In order to render correctly, the SVG tag needs to have width and height styling applied somewhere, either from a CSS style sheet or with inline styles. To use this format successfully in all browsers, the SVG sprite has to be injected directly into the DOM. Thankfully, there's a nice little utility that does that for us called svg-injector. It's available from the link on the screen. The long and short of it is that we load the SVG using an image, and then call svg-injector to do the actual injection. And that's pretty much all there is to displaying SVG icons in our app. Okay, let me show you a little bit of what IcoMoon looks like. This is IcoMoon's website. Now, they offer premium versions, but there are a lot of free icons that you can use as well, and that's what we're going to start with. If I go to the IcoMoon app, you'll notice that actually several icons are already selected. That's because it's remembering the session I used to download the icons needed for this app. This is handy because it means that I can come back to this and add icons as needed. You could also create multiple projects. Now, it's useful to limit your icon selection to only the icons that you think your app will need, because there's no reason to include icons that your app will never use. They take up space. So I've selected only the icons that I think my app might plausibly need. Then I can click Generate SVG and More. You could download this directly, but the settings icon might give you some useful stuff as well. I've left most of this at the default. Once you download it, you get a zip file that you can then decompress. Inside that zip file is one special file, symbol-defs.svg. That's the file our app uses to render icons. So what does that look like? So I'm back in my code editor, and this is the SVG file that IcoMoon provided. It's human readable, but you're not going to probably guess much as to what each icon would look like. However, what's important are these little IDs. We can reference each icon in this file using these IDs. Let me show you an example. This is a JavaScript example, but it works equally well in HTML. In this case, I'm returning a snippet of HTML code to render a certain icon named file text. You need two tags, the SVG tag with an appropriate view box and the use tag. This icon file-text2 directly relates to what's in the SVG file. However, that's not enough to actually render the icon visible on screen. We also need to ensure that it has a width and height. In our case, we've done this by using these styles. For Android, we give 1.5 root ems. And for iOS, we give 1.25 root ems. Without a width and a height, chances are good that you won't actually see the icon on screen. Now, we mentioned recoloring icons earlier, and that's a crucial feature of SVGs. If we supply fill current color, the icon inherits the current text color of whatever element it's rendering in. This way, it can automatically inherit the color of, say, what an icon should look like on a navigation bar. So we've covered a lot in this section. We've discussed some important terms, the project's folder structure, how to support multiple device-specific themes in a single app, and how to support additional image assets. In the next section, we're going to get down into the nitty-gritty and start actually creating the code for all of our app's models. Welcome to Section 12, Creating Our Models. In the previous section, we scaffolded the Filer project directory, and we supported iOS and Android themes within the same app. We also downloaded additional image assets. In this section, we're going to look at the following. We're going to look at the persistent store and local storage adapter, the entity model, the piece and text piece model, the note model, and the notes model. First, in this video, we're going to cover the store and local storage adapter. In this video, we're going to look at the persistent store itself, the API that makes up that store, and the local storage adapter implementation. First, let's remind ourselves what our store looks like. It consists of a constructor, which will create the object, and an adapter that's passed in. The adapter will be pointing to whatever storage mechanism we decide to use. In this case, we'll be using local storage. It also has save, load, and remove methods. As you can tell, these save, load, and remove methods are asynchronous. They return a promise, and this promise will resolve whenever the underlying storage mechanism has a chance to complete the request. There's also a make method, which creates the object. it calls the constructor for us by using new, so that we don't have to use a lot of new entity store in our code. We can just call make. The local storage adapter looks almost identical. In fact, it implements the exact same API. So essentially, the entity store is a wrapper for whatever adapter we're using. If we were to use a different storage mechanism, all we need to do is implement the same API, and we can switch it out with local storage, and the entity store will never know the difference. Let's start writing some code. So I should point out that the easiest way to get the code that you're about to see is from the repository on screen. We're going to be creating 3 files, and their locations are on screen. We're going to start with the entity store. So let's open up the code editor and I'll start going through some code. Let's start with the entity store.js file. It lives in the www.js store directory. The store itself is an emitter, so it will emit changes whenever the contents change. So I'm going to include that line first. We also know that we're going to need a private variable to store the adapter. So the easiest way to actually make private variables is to use the new ES6 symbol. Now let's create our class. I also need to return this module. So I'm using System.js in this app as the module bundler. It understands various mechanisms including require and the ES6 import. I'm going to use module.exports and require since it makes the most sense right now. Now let's create our constructor. We know we need an adapter passed in, but we also need to store that adapter in the object. All constructors need to call super, and then we can store the adapter privately. Next, we can create the make method. Now, if you recall, we had 3 methods: save, load, and remove. It doesn't matter which one we start with. I'm just going to start with save. Because entity store is a wrapper, this method is actually pretty simple. However, we also need to emit an event when this command finishes. That was easy. Of course, it really isn't doing any real work. It's just delegating it to another method. But we'll build that in a second too. Load is very similar. However, we need to also emit another event, and we need to make sure that the data is passed on to the next portion of the promise. And as you can guess, remove is also very simple. And that's the file. Now, let's look at the local storage adapter, because that's where the meat of the storage will actually occur. So this file is a little bit more complicated. Let's start with the class. We really don't need a constructor in this case, because it doesn't do anything special. We don't need to store any private variables. So let's start off with the API itself. Let's start with save. Now first off, we need to return a new promise. Resolve is going to be called whenever we complete the request successfully. If there's an error, however, we need to call reject. So let's wrap this in a try-catch. What we're going to do in this adapter is use local storage to save an object. However, local storage only saves strings. So we will need to use json.stringify to convert the data into a string. If this should fail for whatever reason, we want to reject the request with an error. So if for whatever reason an error occurs, we can call reject. Now, I don't like using magic numbers, and a magic number is, say, in this case for an error code of, say, 1. So I'm going to use some constants. Now I haven't defined these yet. We'll do that in a second. So that's pretty simple. Now we're wrapping local storage with a promise to simulate asynchrony. Local storage itself is actually a synchronous API. But because most of the other storage mechanisms we want to use later are asynchronous, it's best to start out asynchronous. So what would load look like? Again, we will return a new promise. And first, we'll load the data from local storage, but it's going to be coming to us as a string, so we're going to have to convert it back into an object. So to convert that string into an object, we need to use JSON parse. We will pass the result of JSON.parse out to the resolve method, which will pass it on down the promise chain. But if JSON parse fails, for example, the string isn't a valid object, we need to throw an error. So let's wrap it with try-catch. Now, if the object wasn't found in local storage, we also want to throw a different kind of error. And that's all there is to load. Remove is actually quite a bit simpler. In this case, we really don't care if the entity is actually in local storage or not. We'll just try to remove it anyway. So we don't have to worry about the reject case. We need one more method, and that's the method make. And there we have it. This is our local storage adapter. Now this is about as simple as local storage adapters can get. Other storage mechanisms require a bit more work. Of course, before we go anywhere else, we also need to make sure that we return the adapter as a module. Now, before we finish the video, we need to define those constants. So let's go do that. So if you recall, we had codes and messages. So I'm going to start with the codes. We had entity not found, JSON parse error, JSON stringify error, and just for completeness sake, I'm going to also return OK. Now, these numbers aren't important because we'll be using these constants everywhere else. So we could just as easily have made entity not found be -999. Let's define our messages. The messages are just really there for debugging purposes. Since we may not always remember that entity not found is a 1 and JSON parse error is -1, when we're debugging error messages, it's helpful to actually have something that's readable. So with all of this, we've completed the code necessary for our store. In the next video, we're going to focus on the entity model. In the second video of section 12, we're going to cover the entity model. In the last video, we discussed the persistent store and the local storage adapter. We're going to be using those in this video. But first, we're going to review the entity model itself, and then we're going to write some code. This is our entity model. It extends emitter, so it can send events and other objects can subscribe to those events. There's a lot going on here because it serves as basically the base of all the other classes we'll be creating. It has a private variable, store, which is a reference to the store provider. It has a private method, overlay, which is intended to copy data into the instance. and a private method pre-serialize, which creates a separate entity that is serializable. In short, essentially, it removes all the functions and private symbols from the object and returns a new one. The public API includes the constructor, which creates an instance of this class, the unique identifier, get and set methods that set properties, and these will also fire changed events, deserialize, which copies the JSON into an instance, declassify, which creates a serializable entity from this instance. It's really just a deep clone of the object minus functions and private properties. Serialize will export JSON from the instance, in short, returning a string representing the object. Save, load, and remove will work with persistent storage to perform those actions. We have two static methods, make, which creates an instance of this class, and makeUniqueIdentifier, which creates a unique identifier. Before we look at some code, I do want to share with you how the save and load or serialization and deserialization process works. So on the left is the save and serialization process flow, and on the right is the deserialization or load flow. They look very similar. Let's start with the one on the left. So when we go to save something, the first thing we will do is declassify the object, returning a deep clone of this entity. This strips out functions and private properties, but it also makes it a completely separate copy, so that if we need to change something within this new entity, we won't affect the original object. We then call pre-serialize. This gives it a chance to make any changes necessary to this new entity to make it more serializable. So, for example, we might need to store an array of notes as an array of unique identifiers that essentially point to each note. Then we call save on the store. The store will then take the new entity and save it with the unique identifier. Serialization follows pretty much the same process, except instead of saving it, it returns a JSON string. When deserializing the data, we first parse an incoming string and then call overlay with that new entity. That overlay routine then copies the properties of that separate entity onto the current object. It then emits a changed event. Load is very similar, except instead of parsing a string, it loads it from the store. But the result is still passed to overlay, and it emits a changed event. So now let's look at some code. If you haven't already downloaded the code from the repository, I suggest that you do so. It makes it a lot easier because we're starting to get into code snippets that I can't type out in a single video. The JavaScript file that we're creating is in the www.js lib folder and named entity.js. So let's go through this file. I've gone ahead and folded each method so that we can cover them separately without getting terribly distracted. Let's start with the constructor. So, as with all constructors, we have to call super. And then we store the reference to our store. Now, this is using a symbol to act as a private property. Next, we want to see what kind of data is coming in. So if it's a string, we will pass that data to deserialize, which, if you recall, will execute a JSON.parse and overlay that data onto the instance. However, if the data is an object, we want to just overlay that data. This lets us call the constructor and say provide a unique identifier instead of it creating one for us. This is useful when we know what the unique identifier will be, or if we want to provide defaults. If neither of these conditions are true, we will just overlay a blank object. Overlay knows how to tell the difference between a blank object and a property we want to overlay. So if it's blank, it will provide suitable defaults. So since we've talked about those two methods, let's take a quick look at them. I'm going to start with deserialize. Deserialize is pretty simple. First, it tries to parse the data. It's possible that the string you're passing me is not a valid object. So if it fails, it will throw an appropriate error. Once the object is successfully created, it will call overlay. So let's take a look at what overlay looks like. Overlay is not a terribly complicated method. Its intention is simply to either copy a property from the past in data, so in this case, unique identifier, or provide a suitable default. In this case, it will create its own identifier. Now, apologies, this looks like a comment, but it's really an or. It just happens to be my syntax highlighting that is italicizing this. So next, let's look at set and get. Set will copy the old value, change it to the new value, and then it will emit two events. It will emit a key changed value, passing the old and the new value, and it will also emit a general changed event with data including the name of the key and the old and new values. Get is a lot simpler. All it does is return the value. Now technically we can just set properties on an object without having to have get and set. However, that means we have to trigger changed events manually. Now sometimes that'll be what we want. We may want to change a lot of properties and then emit a single changed event. But for consumers of this object where we want a changed event to fire for every change we make, get and set are the best ways. Now I also have a short little method here that returns the private store. This is because I didn't want to have a store property on the object, or declassify wouldn't know how to copy it correctly. Next, let's look at serialize. Serialize calls a method called declassify. It then checks to see if a pre-serialized method has been defined. If it has been, it passes it with this new copied entity from declassify. It then attempts to stringify the entity. If it fails, it throws a new error. Let's look at declassify first, since that's the first thing that occurs. Declassify is a little bit more complicated, and essentially that's just because it's performing a deep clone of the object. First off, I have a breaking measure. This means that if for whatever reason the object has too many levels, it's going to throw an error. Typically, you won't have objects nested this deep, so what it's really trying to prevent is infinite recursion. Next, we store a reference to the incoming object. We then check if it's an array. If it is, we create an appropriate entity. It will either be an array or an object, but these are empty. The reason we're creating them empty is because we're creating a new copy. Changing this copy then will not affect the original. If the incoming object is undefined or null, we just return. If it's an instance of a date, we return a new date. This, again, makes it a copy instead of a reference. If it's a string, we return a new string. The meat actually occurs here. So what we do is we grab the property names. For an array, this will happen to be the indices and length. If there are properties on the object, we will then execute this block of code. What does this code do? So first, it goes through the list of properties. We obtain the value, and if we're in an array and the key is length, then we skip. The reason being is we don't want to copy a length value into a new array because that actually creates new entries. The same is true if it's a function. We don't want to copy functions to the new objects. Functions won't serialize anyway, so we may as well not have them. We then call ourselves again with that object, increasing the level. This is why it's so important to prevent infinite recursion. But what this does is it ensures that if we need to, we can copy the object at a deep level. So if there's a date deep within the object, we know we will get a new version of the date instead of the old copy. If there aren't any properties, or it's not an object, we simply return any other value that gets to this point. So that's a lot of work for what's essentially a very simple operation. If I were to call this on this current entity with only unique identifier, the result is a new object that only includes the unique identifier. It does not include the methods or any of the private properties. The next thing that serialize does is called pre-serialize. In this case, pre-serialize does nothing. It simply returns. Pre-serialize exists for one reason. It exists to give subclasses of this class a chance to modify the incoming entity. For example, that array of notes might need to be turned into an array of unique identifiers. Save follows a very similar pattern. It calls declassify, returning a deep clone of this object. It calls pre-serialize if it exists. And then instead of returning a string, it returns a promise to save the entity to the store. Let's look at how we load an entity. What we do first is request it from the store. We request it using a unique identifier. So we assume this instance has already been set up with at least a unique identifier. Once we get a response, we overlay that data onto this object. If emit is true, which it is by default, we then emit a changed event. Remove isn't very much more complicated either. Instead, it calls the store and asks for it to be removed, and then emits a removed event. Let's look at a couple of the static methods. First, there is a static declassify. All it does is call the instance declassify method. Next, let's look at make unique identifier. The code for make unique identifier is copied from the Stack Overflow question. This isn't something we would typically use in production because it's not actually guaranteed to be unique. It really depends upon how well your random number generator generates random numbers. For our case, however, it's unique enough. What it will do is return a unique identifier in this format. Next, let's look at make. All it does is return an instance of entity with the data and the store that is passed in. In this video, we covered the entity model. In the next video, we're going to extend entity into a piece and a text piece. In this third video of section 12, we're going to cover building the piece and text piece models. First, we're going to review the models themselves, and then we're going to get into writing some code. So this is what the piece entity looks like. It essentially represents part of a note. It has a unique identifier, a type that identifies the kind of piece it is, and this isn't so much important now as it will be later. The title of the piece, the text content of the piece, and just for fun's sake I threw in color as well. We're also tracking the date it was created and the date it was modified. There are some methods in here that are also useful. A private method overlay, which copies the data into the instance. This is overridden from entity. And then some utility methods like getPrettyModifiedDate, getTextContent, and getImageContent. There's also a static method, make, which creates the instance. Now, piece is generic. In a sense, it's an abstract class. It's not intended to be instantiated on its own. Because eventually we want to have many different kinds of pieces in our app, we need to be consistent and at least create a piece that's specific for text. So text piece extends piece. It does everything that piece does, but it's not generic or abstract. It overrides overlay, essentially just to make the type text piece. Otherwise, it is pretty much identical to piece. We need to create 4 files for piece and text piece. The first is just a constants file. It exists to store things like text piece and later audio piece and other things. Rather than having to refer to these as strings everywhere, I can refer to them with a constant. I also need to create the piece and text piece models, and we need to create a piece factory. Let us start out with the piece constants file. This lives in the www.js constants folder and is just named piece.js. It simply, right now, is exporting two strings, piece type, which has the string value piece, and text piece type, which has the string value text piece. Throughout my code, I can use this to refer to the types rather than having to use string values, which I might misspell later. At least here, if I misspell these, I should get an error. So let's look at piece. This is in the www.js models folder under the name piece.js. Like before, I folded the code so that we can go over it part by part. Now, piece extends entity, which if you recall is also extending emitter. So piece inherits all the behavior of entity and emitter. As such, we don't actually have to do a lot in this class. Really, all this class does is add some additional properties in overlay and provide some additional utility methods. So let's look at overlay. We call super overlay, which ensures that the unique identifier gets copied over correctly. Everything else is for our own instance. Each instance needs to have a type, title, content, color, date created, and date modified. And so, if present in data, we will copy them from the data object. Otherwise, we will copy them from our defaults. And notice here, I'm using piece type constant. There is no great default for title and content, so I leave those blank. For color, I'm using inherit. We're just using CSS colors for now. It's not ideal for the end user experience, but it does make it easy for us, and it's just a fun little additive. Date created and date modified receive date.now for defaults. Something that you might not have considered is the fact that we might be calling this after we have loaded from local storage, which can only store things as strings, which means any dates that we have stored will turn into string values. So to make sure that these are actual dates, I recreate them if they aren't already dates. So I mentioned that we had some utility methods earlier. Let's look at those. getPrettyModifiedDate is a utility method that returns a better formatted date. It's not ideal. You could do a lot more here. Right now, all it does is render the time if the date was modified less than a day ago, or render the date instead. This keeps the date or time shorter on the screen. But you could emulate things like Twitter and Facebook, which might say, note created 5 minutes ago. getTextContent returns a formatted version of our piece. It includes title as an H1 and the content in a paragraph. ImageContent returns null because this piece has no imagery. This is just there for later purposes because we know eventually we want to add pieces that have images. And static make. All it does is return a new piece with passed in data and store. And that is literally all that is in this file. Piece is really simple because entity is doing all the hard work. Text piece is even simpler yet. It has two pieces in it, overlay and make. Now, you can guess what make means. It returns a text piece. Overlay simply changes the type to text piece type. Because it extends piece, this overlay does everything this overlay did. So text piece is really simple. Other pieces won't be quite this simple, as we'll have to provide other functionality. So let's look at piece factory. First, why do we need a piece factory? A factory makes it easy to create object instances from classes. In a way, you can argue that our make methods that are static on all the other classes are factories in a sense. But I like to use factories when I may need to create different types of instances. For example, if our app needed to create a piece that represented text versus audio versus an image, I don't want to have to put that switch statement or an if statement in my code all over the place every time I need to make that decision. Instead, it's easier to delegate that to a method, and then I can call it and I'll get the appropriate piece back. That's what this factory does. The only method in it is make, but it takes the type and the data and the store. Depending on the type, it will return the appropriate kind of piece. So a text piece type gets a text piece. A piece type gets a piece. And if it doesn't know how to make it, it throws an error saying, we can't make this piece. In the future, you would add additional piece types such as audio, images, or video. And that's all there is to piece and text piece. In the next video, we will cover the note model. In this fourth video of section 12, we're going to go over the note model. In the last video, we looked at the piece and text piece models. Now we're going to look at the note model, which will actually consist of multiple pieces. We're then going to write the code. Now, note is also an entity. You'll also notice that it looks like it has a lot of the same properties that a piece has, and this is true. It has a unique ID, a title, content, color, and dates created and modified. One key difference, however, is that content is not text. Content is an array of piece. Like piece, there are some utility methods like getPrettyModifiedDate, getTextContent, a couple of static methods, and a couple of private methods. Let's go over the code for those. We only need to create one file for this video. It's in the www.js models directory and named note.js. I'm back in my editor and we're on the note.js file. This is in www.js models folder. Like piece, we've overridden some methods that support the note. Overlay will, like before, supply any necessary properties that a note needs. But we've got some additional methods here that we also need to override, mainly to provide support for handling an array of pieces. Let me start with overlay though. Overlay looks a lot like the overlay from piece. However, a very key difference is this section, this.content. Assuming content is not passed in, the default is an empty array. That's because content is an array of pieces. Now, to deal with an array of pieces means that we have to change the way we handle saving, loading, and removing. Let's look at save. Save takes every item in the content array, which is a piece, and calls its own save method. So every piece will be saved. It combines this into a promise.all, which resolves when all the promises have finished. Once all the pieces have been saved, then we can save ourselves. Now, if you recall, save eventually calls pre-serialize. Pre-serialize, in this case, receives a copy of this note. The copy is something we can change. It is a deep copy. Changing it will not affect the note. So what we need to do instead of saving the entire note is that we need to convert the content array into an array of unique IDs and types. And that's what this does. For every piece, return the piece's unique ID and its type, and put it into an array. Then, when we go save ourselves here, it will actually save the note with an array of unique identifiers instead of an array of actual piece objects. Load also needs to be handled differently. First, we'll load ourselves by calling superload, but we're going to prevent it from emitting a changed event because we're not actually fully loaded yet. To be fully loaded, we need to load each piece as well. So, for everything in content, which will be a unique identifier and a type, we need to return promises that will load each one. This is where it's useful to have the piece factory. We know the type and we know the unique identifier, which is an item. Once the piece has loaded, we can replace it within the note's content here. Then, when all the promises have completed, we can emit changed. This means that the note is fully loaded. Remove first removes ourselves and calls remove on all the pieces. We also have some utility methods. The first is remove piece. This allows us to tell the note to remove a piece instead of the piece to remove itself from a note. First, we allow the caller to pass either the piece or the piece's unique identifier. Then, we try and find it inside this note's content. If it exists, we eliminate it from this note's content by filtering it out. We then ask that piece to remove it from local storage and then save ourselves. On the other hand, if it wasn't found, we simply reject. Get pretty modified date is very similar to the one from pieces. Get text content takes all the pieces text content and joins it together. Get thumbnail image tries to find the first image in the note. Now none of our pieces will actually have image content yet. So instead, we return a default, which happens to be an SVG icon representing a file. However, if it wasn't, we would return the image itself. We then have static make, which creates a new note. And we have another utility method, which creates a new note, but also sets the pieces to the pieces we pass in. In the next video, we will work on the notes model, which is a collection of notes. In this last video of section 12, we're going to work on the notes model. In the last video, we created the note model singular. In this video, we're going to review the notes model plural and write the code to handle the notes model. Our model this time will actually be a collection of singular note. So let's look at the notes model. Like everything before it, it extends entity. It has an overlay private method, which will copy data into the instance. It has an overridden pre-serialized method, which will convert an array of notes into an array of unique identifiers. It has content, which will be an array of note, and save, load, and remove methods for handling storage. It also has a remove note utility method. It has a static make method, which will create an instance of this class. We only need to create one file for this video. It's in the www.js models folder and is named notes.js. Let's take a look at the code. So here I am in my editor, and I've got the notes file up and loaded. It looks a lot like the note file we just looked at in the previous video, but there are some important differences. Let's look at overlay. Now, notes extends entity, so it only otherwise has a unique identifier, which means we only have a unique identifier from super overlay and a content array. This content array stores an array of the note class. As with note, we need to change how we save, load, and remove ourselves from storage. Let's look at save first. First, what we do is save all the note objects in our note collection, which is content. When all the promises have returned, we can then save our own self. Like with note, saving ourself we'll call pre-serialize. Similar to note, we need to correct the entity that will be saved. Instead of saving an array of note objects, we just need to save an array of note unique identifiers. After all, we've already saved the notes themselves. Likewise, load needs to be updated. Again, we load ourselves first, and then we attempt to load each and every note. We do this by creating a note with the unique identifier, which we already know about, and then ask it to load itself. When it's loaded, we can replace it into our content array. When everything has been loaded, we emit changed. Remove calls remove on ourselves, and then remove on every note in our content array. Remove note is a utility method that allows us to easily remove a note from our collection of notes. We can pass it an actual note object or just the unique identifier. Either way will work. First, we find the note in our content array. If it exists, we filter it out so that we don't have a record of it anymore. We then remove the note and save ourselves. If the note isn't present, we reject with an error. Finally, we have a static method make, which returns a new instance of this class. And that's all there is to our notes model. In this section, we've covered quite a bit. We've covered how persistent storage works and how we use local storage to save our data. We've covered the entity model, the piece model, the text piece model, the note model, and finally, the notes model. In the next section, we're going to start building the visual component of our app. Namely, we're going to be listing our notes. Welcome to section 13, listing our notes. If you recall, in the previous section, we built our app's data model. Now it's time to build the visual components and the glue code that connects everything together. In this section, we're going to look at the following. We're going to create the HTML and CSS for our list of notes, and we're going to create the JavaScript that puts it all together. In this first video, we're going to focus on going from the design to the view. In this video, we're going to look at the following. We're going to create the list item template, we'll create the notes page itself, and we'll apply some CSS styling as necessary to make the page look nice. So through the magic of editing, we've been able to jump into the future so that you can get an idea of what the app itself looks like. This should hopefully give you a better idea of how everything we do in this section and the following sections actually work together to make the app look as it does. So on the right is what Filer looks like on iOS. This is the Notes page, and it's just a list of note items. The page itself consists of two items, the navigation bar at the top with icons, and a scrollable, sortable list of note instances. A sortable list in this case indicates that the user can grab a handle and reorder the list. On Android, the plus icon in the upper right is actually a floating icon at the lower right corner. Each note is rendered with a list item template. In this template, there is an image to the left, the title and time are on the top, a portion of the note is visible, and there's a chevron indicating that this will go to another page. All items support swipe to delete, and if the user desires, they can all be reordered. So with this in mind, let's look at the code. There are 3 files that we will need to create. First, 2 files in the HTML directory under the www folder. One will be the page itself under the Pages folder and named notes.html. One will be the list item template named noteslistItem.html under the Templates folder. For styling, we will apply styles in the notespage.css file under www.css. So here's the notes.html page. It lives under www.html pages. This is what renders the page itself. You'll notice that we include the navigation bar for iOS and Android. We also name the page Notes. This is important for applying styles and listening to events. Otherwise, we would have no mechanism for listening to page-specific events or applying page-specific styles. Also, if we're on Android, we include the floating button that has a plus icon in it. Then we include the page content, which is simply a list. It's a media list because we will have images on the left, and it is sortable. We don't include anything else in this because we'll be filling it later. This list will actually be populated with note list items. So let's look at that file. This file lives under the www.html templates folder and is called noteslistItem.html. You can tell that each list item is actually fairly complex. In order to support swiping, it needs to be surrounded by a list item with class swipeout. The content then gets swipeout-content in a div. Let me skip this portion and go to the swipe to delete. This is all that we have to do to actually support a swipe to delete action. Framework 7 is smart enough to add the gesture necessary to reveal the delete item. For sorting, we also need to include a div that allows the user to drag items around. Again, Framework 7 is smart enough to display this when appropriate, and is smart enough to reorder the list as appropriate. Now let's go back to how each note is rendered. Each note is surrounded by an anchor, and this anchor includes the note's unique identifier and title. It also has these classes, item content and item link. The link part is necessary to display the chevron. We also force a given height, in this case 88 pixels, and we render the text in the note's color. For the picture that displays on the left, we use div class item media and call the note's getThumbnailImage method. For everything else, we have an inner item div that has a title row, the title, and the pretty modified date, which if you recall will just be a time of day or the date, depending on when the item was modified. We then render the item text. We use a specific color, and we ask the note to display all of its text content. But because we've specified a specific height, that will get cut off as appropriate. Next, we need to look at the styling. Framework 7 generally handles most of this for us, but there are a couple of things that we need to modify. So, in notespage.css, here are the styles for the notes page. We make our title bold. We specify a width and height for the SVG in our media section or the thumbnail section. If we didn't specify a width and height, it would just not appear. And then, if you recall, the text rendering for each note comes with an H1 and a paragraph. So, we specify some appropriate sizes, eliminate the margins, make the H1 bold and the paragraph normal. And that's all there is to the notes page. We do still have to write the JavaScript, however, that puts all this together and handles clicking and other events. So that's what we'll do in the next video. In this last video of section 13, we're going to write the JavaScript that handles the notes page. In this video, we're going to look at the following: the JavaScript for the notes page itself, and we're going to cover how page routing works in our app, including how we navigate to the notes page when the application starts, how we navigate to a note if the user taps or creates one, and how to handle Android's back button. Before we go into any code, we need to discuss the page lifecycle. You can see some example of flows for the notes page on the right. The important part is the flow for show notes page. You can see that it does a lot of work, including attaching callbacks, calling init, configuring icons, creating lists, loading notes, and various other things. To start all of this off, however, we're going to create a utility method called app.go. We'll be able to pass a page to this method, and it will control the rest from there. It will call an init method on the page, which we can use to wire up any event handlers that we need to have in place. For example, if we need to perform some action if a button is tapped. It also adds handlers to Framework 7's page callbacks. These are fired by Framework 7's at particular stages during the page lifecycle. Most of them occur before or after animation of the page, but some of them occur before its removal from the DOM. Some of these occur before the page is going to be removed from the document object model. The most important ones include on-page init, which occurs when the page is going to be displayed, on-page after animation, which occurs after the page has animated onto the screen, and on-page after back, which occurs when the page is about to be taken out of the document object model because the user navigated backwards on the view stack. On-page after back we'll call a destroy method in the page, which allows us to unwire all of our event handlers. It's incredibly important to undo whatever listeners we created when we initialized the page. Otherwise, as the user navigates between various pages in our app, we actually end up creating multiple listeners for the same event, and mayhem will then ensue. At this point, we can start looking at some code. There are two files that we're going to either need to create or modify. The first we're going to need to create is under www.js pages notespage.js. We're going to need to modify www.js app.js to include the routing functionality. Let's first start out in app.js. We're going to create a method that handles the routing for us. We'll call this whenever we want the app to navigate to a new page. So, as you can see, app.go takes as parameters a page and a flag whether or not it should be animated or not. This animate is only used when the application starts, so that we can put the notes page on screen without animation. If the page understands the init request, we then call it. We then create handlers for every one of the Framework 7 callbacks. There are several: on page init, before init, re-init, etc., etc. For each one, we create a listener, and if the page understands it, we will call it. We also create a remove handler, and this is listening to on page after back. It will remove all the page callback handlers that we just created here so that they're not hanging around unnecessarily. It also removes the handler we just created, and if the page understands destroy, it will call that. We then tell Framework 7's router to load the page. The page includes a template, some context, and we pass an animate from this switch. We also provide a simpler utility method for going backwards in the view stack, and all it does is tell the router to go back. So while we're in app.js, let me show you how we're going to push the notes page on screen when the app starts. This section should be familiar. We've created the application's main view, and this just comes from Framework 7's template. In this particular section, we just create a global reference to the entity store. To create a page, we just make it and pass in the appropriate store. Other pages may require additional information, such as unique IDs, in order to fully create themselves. We then pass this page to app.go. In this case, we say don't animate because this is the first page in the app. This is stuff we've already covered in previous sections. And then, since we're already here, we do need to address the Android back button. iOS has the back button on screen, or supports a left to right gesture to go backwards. Framework 7 takes care of this on its own. However, Android also has a physical back button. We need to catch that event and navigate backwards, and that's what this block of code does. This is actually a Cordova event and not a Framework 7 event. In order to determine how we should react, we check the number of pages that are in the document object model. If there's more than one, we know we can go back safely. However, if there aren't more than one, we exit the app. This typically mirrors Android behavior. Now, let's look at how the notes page itself is implemented. First off, there's a lot of things imported from other modules. That's because we're finally doing a lot of work gluing everything together. Let's look at the notes page class. First, we have our constructor. The constructor is fairly simple. It sets the page name, it pulls in our template, which is from here, and it is our Notes HTML page that we covered in the last video. Now, notice one thing. We're compiling it. We do this so that we don't have to recompile it down the road. Whenever possible, you should always try to compile templates, but you don't want to compile them multiple times, just once. It also has a context. Now, this isn't the list of notes. This is information about the page. So, the page's name, the title we want to display on the navigation bar, and the left and right icons on the bar. We keep a copy of the store, and we make our notes instance. Now, most of our entities use proper unique identifiers, but we do need to know how to load our notes collection, and so we just use a fixed ID. This .list is going to be a virtual list. We don't know how many notes we might actually have to render on screen. It could be 1, none, 5, or 1,000. Framework 7 has a virtual list that makes it performant even with lots and lots of items. Let's go in order of the page lifecycle. So once we tell the app to display the page, it will call the init method. Now in our case, we're not doing a whole lot, we're just delegating it to wire event handlers. So let's look at that. And there's a lot of code in here. All we're doing is listening to a lot of events and defining what we do in response. The notes and store entities will send off various events that are important to us, and so we listen to those. The same is true if the user wants to delete a note. Likewise, if they want to tap a note, add a note, tap the info button, tap the edit icon, and then tap a checked icon, and change the sort order of the list. There's a lot going on here, and we're going to come back to what each one does explicitly in a moment. Once the event handlers are wired up, the next method that will be called will be onPageInit. This is fired before any animation actually occurs. It's a great place to do initial setup. Now, if you recall, we had several icons visible on screen, but if you recall the image, we only had a couple. That's because a checkmark icon that we have present will be hidden by default. The idea is that the user will tap pencil, which is edit, the pencil will disappear, and then the checkmark will appear, and when they're done editing, they can tap the checkmark to bring the pencil back. Next, we create the virtual list. This is a Framework 7 function. We need to tell it what items to have in the list, and initially we don't know, so we just pass an empty array. We need to tell it how high each item will be, and we use 44 times 2, or 88 pixels. This is largely arbitrary, but it seems to work best for our case. And then we pass a template. This template comes from the Notes List Item HTML page. Once we create that list, we ask our notes to load themselves. If there's an error, however, it might mean that no notes exist. Rather than render a completely empty list, it's nice to provide some default data, and that's exactly what we do. If the entity that isn't found is our notes entity, we will create some default notes. We then save them so that we won't have to do this again. For any other error, we just throw an error. The next method that will be called is onPageAfterAnimation. All we do in this method is make sure that the list is not currently being sorted. This is important because if, say, we leave the list in a sortable state and navigate to an individual note item and then return, the list would still be in a sortable state. This really probably shouldn't be, so whenever we navigate to the Notes page, we make sure that the list is not currently sortable. Let's also take a look at what that makeDefaultNotes method is doing. What it does is it sets our notes content with an array of notes with pieces. For example, this is the first note that is created, and it's a welcome message. We have other ones in here as well. Although it's nice for the end user, it also makes it easier to test things since we're not starting out from a completely blank slate. Now, loading the notes or making default notes and then saving them triggers something else, a notes changed event. If you remember from wire event handlers, we have attached a listener to that event. Let's take a look at that. On notes changed, we'll simply replace all the items in the virtual list with the new note items. We also need to respond appropriately when something changes or is removed from our persistent store. We've attached handlers for changes to the store as well. When something is saved in the store, what we will do is try to see if it's a note included in our collection. If it is, we will then request that note to load itself, and then determine if we need to replace it in the virtual list. This ensures that it's now visible to the end user. If it wasn't found in the virtual list, however, it means that we were adding the note, and so we add it to the virtual list. If an entity has been removed, we need to do the reverse essentially. We find it in the list, and if it is present, we delete it from the virtual list, and then proceed to remove it from the store. Okay, let's look closer at our wired events. A note can be deleted when the user swipes on it. We can look for that by listening for a click event on the swipe out delete element. If it is triggered, then we need to determine the element's unique identifier. We can do this by looking at the event's target and navigating the document object model to find the anchor. In this case, we can go up to the parent, then to the previous element, find the first anchor, and then we can obtain the unique identifier. Now, Framework 7 will go ahead and remove the item from the virtual list, but we also want to make sure to remove that item from the store. So that we don't rebuild the virtual list too soon, which stops any animations in their tracks, we wait for about 350 milliseconds. This gives the animation of deletion time to complete before we physically remove it from the store. If the user taps on a note, we need to navigate to the note page. Now we haven't created that yet. We'll do that in the next section. However, we can figure out which note needs to be displayed by searching for the closest item link to the target that the user tapped. We then find the unique identifier and the title, and we create the note page with both of those. And then we ask our app to navigate to the note page. Adding a note is similar, although first we have to create a new note before we can navigate to it. So we create a new note with some default data. We then add it to our own content, and then save ourselves, which will save the note. Of course, this will also trigger ourselves to update the virtual list. We then, when done, create a new note page and ask the app to navigate to it. There are two ways to add a note, depending on whether or not we're on iOS or Android, and so this is why we have two handlers. If the user taps the info icon, we display the About page. If the user taps the Edit or Pencil icon, we display the checkmark icon and hide the pencil icon. We then tell Framework 7 to open the list for sortability. This displays the sortable handlers, and Framework 7 knows that the user will now be reordering the list. If the user then checks the check mark, we do the reverse. We hide the check mark, display the pencil, and close the sorting operation. When something is sorted, it fires a sort event on that specific list item. We can listen to that and then act appropriately. If the user sorts the list, things get really complicated at that point. So I'm not going to go over everything here. I'm going to let the comments in the code explain them. You are more than welcome to look at the code repository, but we're long enough as it is, and sorting the list isn't necessarily an essential feature. Next, we need to go over how our events are unwired. Actually, for the notes page, this actually will never occur because the notes page is the initial view. Even so, we've included the code so as to be consistent. When the page is removed from the document object model, destroy will be called, which will call unwire event handlers. All unwire does is unsubscribe or off every handler. In the next section, we're going to build the note page, which is a list of all the pieces, and the text editor that goes along with it so that you can actually make changes to each note. Welcome to section 14. In this section, we're going to focus on adding and editing notes. In the last section, we built the notes list itself. In this section, we're going to create the HTML and CSS to display a single note and to allow the user to edit any parts of that note. We'll also create the JavaScript to accomplish the same thing. In this first video of section 14, we're going to go from the design of the note page and text piece editor to the actual HTML and CSS representation. Specifically, we will create the text piece template, the note page itself, and the text editor. We'll also apply CSS styling to make it look as we expect. On the right, you can see what a note looks like on iOS. Android looks very similar. At the top is the navigation bar with icons. I should also note that the title itself is editable, so if you tap it, an alert will appear asking for the new title. The page itself is a scrollable, sortable list of note pieces. You can have as many note pieces as you want, from 0 to who knows how many. There's an Add Text button at the bottom for iOS, and if you're on Android, you get the floating plus button. Each piece is made up of a template. This template uses a card format. This allows each piece to have variable height. It also, unfortunately, means that we won't be using a virtual list. But the chances of having a large number of pieces in any given note that would cause performance issues is probably slim to none. In this card, the title is at the top, the note itself is in the card, and there is a date modified at the bottom. Each card supports swipe to delete, and each card is sortable. The editor for our text pieces is really quite simple. It includes a navigation bar at the top, which includes the ability to delete this piece if you didn't want to swipe to delete on the previous page. And it includes a text editor. This is just a text area element. Visually, not very exciting, but it gets the job done. Now, let's look at the code behind this. For this first video, we're looking at HTML and CSS only. There are 4 HTML files that will need to be created. There are 2 CSS files, one of which is new and one of which needs to be edited. So back in my editor, I'm currently in the note.html page. This lives under the www HTML pages folder. It's not much more complicated than the notes page that we looked at in the last section. At the top are our navigation bars. One key difference is that we are including back text. Now on iOS, this renders as a chevron and the word back. On Android, however, it doesn't render the word, it just shows a back arrow. However, we need to have something here so that our partial knows to show a back button. If we're on Android, we also add in the floating button that lets us add pieces. Next, we have the div that marks the page's content, and we are using a sortable list. Inside that list, we have an unordered list, and we call this page's render pieces method. If we're on iOS, We also add a way for the user to add text to this note. Next, let's look at the list item itself. The list item doesn't contain quite everything that we might have had in the notes list item in the previous section. Mainly, this is because in the future we might have different kinds of notes. So, this is where we include a render piece helper. In the next video, we'll go over the simple code that makes this work. But essentially, this helper returns a template for whatever piece we're trying to render. So this list item template essentially just provides the wrapper portion. It is a swipe out item, so it supports swipe to delete. It's also sortable, so it supports a sorting handler. Inside, each item has an anchor with the unique identifier, a title, and the type of note, because this is important later when we need to determine which editor to show if the user taps it. And we also render the note in its color. The goal of this helper will be to render a specific piece. Right now we only have one, and that's a text piece. So let's look at that. This is the template for a specific text piece. You'll notice that we're using a card format. In fact, actually, this card is embedded in a list. We need that list to gain support for swipe to delete. However, inside that list item, we're going to use a card because it supports variable height, and we may never know how high or tall a note will render. The header is styled in the note's color and uses the note's title. The piece's text is rendered inside the card's content. And in the card's footer, we display the last modified date. Now let's look at the CSS we need to use to make this work. Like before, there's not actually a lot going on. This is because Framework 7's default styles are largely sufficient. However, we do need to make some changes. So in notepage.css, the first style is making the cards look like they're lists items instead of cards. Framework 7 typically applies margins and padding to these cards. That looks a little bit strange when you also then swipe to delete the item. So in this style, we're removing that entirely. Cards also don't know exactly how to be sortable. They will display the handler, but they will also take up the wrong width. And so this calculation fixes that. Next, we just apply some cosmetic changes. We don't want there to be a left padding on a list, which is typical on iOS. Again, this looks strange when you use swipe to delete. We allow the header to be bold, and we use white space pre-dash line for the card content. This allows our card content to gain line breaks as appropriate, but it also allows it to word wrap. Now that handles the list of note pieces. Should we wish to edit a piece, let's look at Text Piece Editor. Text Piece Editor is really simple. It has the navigation bars, page content, and although it looks like we're building a list, we're just using a list because that's how Framework 7 handles form elements. It has only one list item, and it is a text area. This is the area in which the user will edit the note. Now, this text area needs one particular piece of styling because otherwise it'll be pretty small on screen. So in styles, we have this style here, which says that a text area needs to be at least 50% the height of the viewport. In the next video, we're going to cover the underlying JavaScript code that glues all of this together. In this last video of section 14, we're going to write the JavaScript that makes the note page and the text editor work. In the last video, we looked at the HTML and CSS necessary for our note and editor pages to work correctly. In this video, we're going to focus on the JavaScript. we're also going to look at how we navigate to the Note and Editor pages. Next, let's look at the code. We'll need to create 4 files, 2 for each page, a helper, and a factory that will help us determine which editor to show. Now, right now that sounds a little redundant because we have only one editor, but we're going to include it anyway for future expandability. Now, I've got NotePage.js loaded in my editor. Let's look at the various methods. First, the constructor. This should look very familiar from the previous section. We have the name of the page, the template that we're using. In this case, it is using the note.html template that we created in the last video. And it has some context. The name of the page's title, or a suitable default if the note has no title. It has icons to the right. We attach a class to the title because we need something to listen to if the user taps it, because we allow the user to edit the note title if they tap the note title. And then, if you recall, our template called render pieces. This method simply renders each piece using a list template. This list template is note list item HTML from the last video. One other important thing to note is that we create a new note using the incoming unique ID. If you recall, the notes page will pass us the unique ID. Now, initially, this note will be blank otherwise, but by virtue of the page lifecycle, we will load this note before we do anything else. So let's go in order of the page lifecycle. The first method that will actually be called is init. Like the previous section, we just call wire event handler. There's quite a bit going on in here, again, but these are all methods that will react when something changes or the user taps something in the app. We'll come back to this method in a moment. Once everything's wired up, onPage init is the next method that will be called. We reset some of the visual state of our view so that the check mark and the trash can are hidden, but that the eyedropper and pencil are visible. And then we tell the note to load itself. Because the note already has a unique identifier, it will load the rest of its properties from the persistent store. However, if the note does not exist, we will create a default note, much like we created a default set of notes when the user didn't have any notes at all. Let's look at Make Default Note now. Make Default Note is really simple. It sets our note's title to a default title and creates a single text piece with the title Tap to edit this piece. If the entity fails to exist for some other reason, we just throw an error. The next method to be called will be onPage after animation. And just like before in the last section, we will close any open sorting operation. Now, because the note was just loaded, it's going to trigger an appropriate changed event. Let's go look at that. First, it updates the note's color. All this does is change the color style of the page's content to the note's color. And it also updates the navigation bar text or background color depending on if you're on Android or iOS. This makes the view reflect the color of the note. And then we update our sortable list with the result of render pieces. In this case, we're essentially just replacing the content entirely. This is different from when we worked with a virtual list where we needed to tell the virtual list what items may have changed. Now, if there were 1,000 items here, this would not be terribly performant. However, the likelihood of that occurring is slim to none. We also need to handle the case that a piece that we own has changed. So when the store sends us an appropriate event, we will load that piece and we will call on note changed. This, as you recall, will regenerate the list of pieces. This is also true when a piece is removed. So, before we get back to wire event handlers, let's take a quick look when someone navigates back out of this page. The first thing that will happen is that destroy will be called, which means we will unwire all of our event handlers. Next, let's look at wire event handlers more closely. We need to have handlers for every icon visible on the page. If the user taps the edit icon, which is a pencil, we will show the check mark and the trash bin icon. We'll hide the pencil and eyedropper, and we tell Framework 7 that this list is now sortable. If the user taps the check mark, that indicates that they are done with the sorting operation. And so we tell Framework to close the sort operation. We also hide the check mark and the trash can icons and show the pencil and eyedropper. If the user taps the eyedropper, that displays a prompt. Now, this is nothing fancy. You could do a lot here with a color selector, for example. All we do is ask for a hex or web color. This prompt method is Framework 7 specific. If the user gives us a color, we update the color, update date modified, save it, and then call update note color, which, as you recall, will update the look of this note. If the user cancels this, we do nothing. If the user taps the title, we throw up another prompt. In this case, we want to know what they want to name the note. If they supply a value, we update it, save it, and update the note title. If they hit cancel, again, we do nothing. If they tap a piece, that indicates that they wish to view or edit that piece. So we find the closest link, get the unique identifier, title, and type, and then we call something that we haven't created yet, but we'll show you in a moment, Piece Editor Page Factory. We pass it the type and the unique identifier and page title. And then we tell the app to navigate to that new piece page. Now, again, we only have text pieces right now, so that's the only option. But in the future, this would allow us to navigate to an audio editor or a video editor, for example. If a piece is deleted, we find the nearest anchor to get the unique identifier, and then we tell the note to remove the piece. Again, to prevent any interruptions to animation, we put this on a timeout. The delete tapped handler is if the user taps the trash can. This is an intent to delete the note and not a piece. A swipe gesture doesn't usually come with a confirmation, but an icon is much easier to accidentally trigger. So here we prompt for confirmation. We do this by using Framework 7's modal method. Now, prompt is really just a specialization of the modal method. We ask if the user wants to really delete it, and then we pass two buttons, cancel and delete. If the delete button is clicked, we tell the note to remove itself, and then we tell the app to navigate back. If the user desires to add a piece, we create that new piece with some defaults. We add it to our collection of pieces, and then we save our note. Once done, we create a new piece editor from the factory and navigate to it. Now, if the user is in sort mode and they sort an item, we need to update our list appropriately. So, we obtain all the items as present in the document object model and then map them based on their unique identifiers. We update our modified date and then save ourselves. And that's the code necessary to make NotePage work. Let's look at the render piece helper method next, since our template in notelist item will use it. Render piece is used to make it easier to have split out templates. That way we don't have to duplicate a lot of code for any piece template. Right now we only have one, which is text piece, and that's coming from the text piece template we created in the last video. Should the piece be of type text piece type, we return that compiled text piece with this as the context. Framework 7 automatically sets this context to the actual piece automatically for us. If we don't know how to render the piece type, we return an appropriate message. That complete, let's look at how the user can edit a piece. Like all the other pages, we have a constructor with the name of the page, the title on the page, and we also pass the template, in this case, text piece editor. We create a new text piece with the incoming unique identifier. Again, like previously, this text piece will mostly be blank until we load it. Like before, init will be the first thing called, which we'll call wire event handlers. We're going to come back to this in a moment. On page init will be the next thing called. We don't have to do a lot here actually, except load the text piece. If that fails, we create a default text piece. Otherwise, we throw an error. The default text piece simply sets the title and content appropriately. After the page is rendered on screen, we focus the text editor. We do this by finding it in the document object model and then calling focus. Now, loading that text piece will trigger a changed event. Let's go look at that. When the text piece is changed, we will update our text piece color, which is just setting some styles, just like in the previous file, notepage.js. We will then find the text area and then tell it the new content. If the user happens to navigate backward, we need to save changes to the note. This will occur by firing on page back. We'll call this save piece. Save piece will load the content from the text area and compare it to our current content. If the user hasn't made any changes, there's no need to save it. If they have, we set the modified date, set the content, and save the piece. Let's go back to wire event handlers. First, save piece on pause. This is a Cordova event, and it's fired when the user backgrounds our app. Because they might not return to it before our app is terminated, we need to save the piece. And so that's what we do. We call this save piece when the user backgrounds the app. If the user taps the eyedropper icon, we prompt them for their desired color, just like before. If they delete this piece, we ask them if they really wish to do so. And if they tap the title, we prompt them for the new piece title. If the user navigates back, destroy will be called, which we'll call unwire event handlers. Just like before, all we do is unsubscribe or stop listening to the events we started listening to here. That done, let's look at the piece editor page factory. This is a very simple piece of code. All it does is, depending on the incoming type, return the appropriate editor page. Again, we only have one, so there's only one choice to make. But in the future, we might have multiple. In this section, we covered creating the note page and the editor page. We covered the HTML, CSS, and corresponding JavaScript. In the next section, we're going to put all of this together, show you the results, and have our final wrap-up discussion. Welcome to Section 15, our last and final section of this video course. In this section, we're going to be wrapping everything up. In this section, we're going to tie everything at the very top level. We're going to demonstrate the app that we've just built, and we're going to go over some ideas for improvement that you might want to implement on your own. So, in this first video, let's wrap everything up. In this video, we're going to look at a couple things. We haven't covered how we're handling modules, and so we're going to do that in the first portion of this video, and we're using System.js for that. Then we're going to cover where we might go from here in future courses. First, you've been seeing a lot of module.exports and require in our code. That depends upon module loading support. To do that, we're using a tool called System.js. You can learn more about this tool at the website on the screen. System.js is a universal dynamic module loader. It supports ES6 import statements, AMD or require.js modules, common.js modules, module exports and require, which is what we've been using, and supports various extras like path mapping. It also has plugin support, which can extend System.js's functionality. In our code package, it lives under www lib system.js. We actually do need a plugin with System.js because our templates are stored as separate files, but we import them like modules. This requires the System.js text plugin at the link on the screen. This plugin lives under www lib system.js plugins. So to use System.js, the first thing we need to do is include it as a script in index.html. Then we call systemjs.config. We pass a blank base URL. This means that all URLs will be relative from the position of index.html. We also pass in a map to the text plugin that we just downloaded. Meta allows us to specify specific loaders for given file extensions, and so we do that for HTML extensions. In short, we want the HTML files to use the text loader. Then, after we configure it, we can bootstrap our app by loading the first main file. We do this by calling systemjs.import and the path to the file. System.js returns a promise that resolves when the file is either loaded and started or if an error occurs. If it completes successfully, then right now we just happen to log app loaded and bootstrapped to the console. However, if an error was thrown, we log the error. This is useful in debugging. If for some reason System.js fails to load a file, this error will help us figure out why. So right now I'm back in my text editor, and I'm showing you a file that we created from the last section. This is a really simple file, but it illustrates almost all of the points of why we use System.js. So, first, System.js understands various module loaders. It does this by looking at the file for certain keywords. So since we're using common.js, it knows we're using common.js because we use the words require and or module.exports. You might be wondering, since we use the latest version of JavaScript everywhere else, why did we avoid JavaScript's import statement? The reason is simple. System.js does not translate that into anything special. So in order for that import statement to work, the browser or the web view would have to understand it. And right now, as of ES 2015, there is no implementation for the import statement. As such, nothing understands how to load anything using it, unless you implement transpilation or other polyfills. We're complex enough as it is, so I didn't feel the need to introduce an additional complexity. Instead, require and module.exports require no special machinery other than module loader support. These things worked fine in previous versions of JavaScript and will continue to work fine in new versions of JavaScript. As such, we're using common.js format, hence require and module.exports. Somewhere down the road, yes, sure, we could switch over to the new import syntax. It's important to remember that require here points to a file. Require will then return whatever that file exports via module.exports. So, for example, in this file, we are exporting this class via module.exports. Any other module that utilizes this module will receive a reference to this class. And likewise, we are receiving references to whatever this file creates and whatever this file creates. Now, these are all JavaScript files, which required no special changes to System.js's config. Let me look at a page JavaScript file to show you an important difference. This is Note page. Now, initially, the require statements look normal. However, we have a require statement here that is loading in HTML, and we are specifying that it's a text file. This isn't JavaScript. So what do we get out of it? With the text plugin in System.js, require will actually return a string, and the string represents the contents of this file. Now, I'm going back to app.js as well, to the very beginning of everything. App.js will essentially require everything it needs to start the app up. Next, let's also look at our index.html file. Here, you can see that we include System.js. We include it after just about everything else because Cordova and Framework 7 need to get initialized as quickly as possible. Then we include an inline script. You should recall these few lines from previous sections. Then here's our configuration for System.js. We then load JS app.js, and if it loads successfully, we log this to the console. Note that loading it successfully means that our app has actually started. If I go back to app.js, we have a small section of code here. If we're not running under Cordova, we will execute start app immediately. This helps if we're testing in a browser, for example. If we are running under Cordova, we will wait for device ready and then start the app. This executes whenever System.js loads the initial file. So by loading this file, our app will start. So where might we go from here? There's a lot of things we plan on doing. For example, we plan on adding additional piece types, including images, audio, and video. These will require using Cordova-specific plugins to access features on the device. We will also add testing and automation features to make sure that our app works correctly as designed, and that if we make changes to it later, that it continues to work correctly. We're also going to add localization and internationalization so that the app feels at home in the user's locale. If they don't understand English, we need to provide translations that they will understand. We also want to make sure that our app is accessible to the widest range of users. We're also going to add a build step. This build step will in part convert our modern JavaScript code to older code that older devices will understand. Right now, you would need iOS 10 or better to run this app and a recent version of Android as well. We will also bundle our code into one file for faster loading. Right now, System.js has to load each file on the fly, which we don't have very many files, so it doesn't take a long time. But in a larger, more complex app, that could add to significant startup time. And we'll design launch images and icons. Now, we also plan on doing a lot of other great things, so look forward to future announcements on those courses. In the next video, we will give a demonstration of the app and go over some ideas for improvement that you might want to undertake. These are simple enough that you should be able to tackle them right now without waiting for any additional courses. But hopefully they are also challenging enough to give you a good sense of satisfaction when you complete the task. Welcome to this last video in section 15 and the last video in this course. Congratulations if you've made it thus far. We've covered a lot of topics. In this final video, we're going to demonstrate the app and provide you some ideas for improvement. So, I'm going to show you the demo in Google Chrome because it makes it easy for you to see what's happening in the console and because I can easily switch between the two device themes. But it works perfectly fine on an iOS device and an Android device. Currently, you're seeing the app on startup using the Material Design theme. The app decided it was running on an Android-like device, so that's the theme it picked. You can see the default notes that we've already created so that the user has some idea of where to start. Now Chrome lets me simulate touches. So this circle that's moving around simulates where I might be touching the screen with my finger. Let's look at the first note, Welcome to Filer. If we tap it, the note appears on screen. And you can also see that some logging occurred over here that shows the page lifecycle occurring. Let's go back. You can see that the page callbacks have been removed over here. Let's look at another note. This note has two pieces. Each piece is independent. If I drag, you can see each one supports swipe to delete. Let's tap into one. This is the editor. Now on a real Android device, you would have a keyboard down here. Since this is Chrome, it doesn't show one. But we can make changes as we desire here. So now if I go backwards, you can see that it has updated here. Critically, it will also have updated here. Now, we talked a lot about notes having colors. Some default notes have colors already. For example, this one has a blue color. This one has a red color. Notice how the navigation bar changes appropriately. However, the piece itself doesn't have any color. Pieces can have color separate from their note. So let's use an example. I'm going to make this color green. The piece updated appropriately, but you can also see that the note itself maintains its red color. The piece, however, is rendered in green. If I go out one more level, the entire note is rendered in red. Now let's look at a couple examples that are given to us by default. Here's one that you might be using for tracking a vacation. So you might include dates, locations, a hotel confirmation number, and a flight confirmation number. Again, each one of these is independent and can be deleted. So let's say for some reason this flight got canceled. Let me delete the flight. Gone. That's simple. If I go out and come back, it does stay gone. Let's say that the location is more important to me right now. I can reorder it by hitting the pencil and dragging up or down as appropriate. Now technically it's already saved this sort order, as you can see in the console. However, from an end user perspective, it makes sense to go ahead and tap the check mark. Now if I go back, you can see that the location is the preview. And if I tap, the sort order is as I left it. Let's look at another example. Here are some gift ideas we might be using for, say, Christmas. Again, we can reorder as desired. And we could edit, like, for example, we know now that Mom wants a salt and pepper shaker set. This list is fully sortable, so if I click the pencil icon, the handlers will appear and I can drag them around as desired. So I might want my gift ideas to be at the top of my list. And if I refresh this page, that list will persist. Notice that gift ideas is at the top. If we want to add a new note, all we need to do is hit the plus icon. Then we can give it a new note title, and we can go edit the piece. And there it is. Now let's look at this with the iOS theme. It looks very similar, except the plus icon that lived down here is now here. It acts exactly the same, however. If I navigate into a piece with multiple items, you can see that it also has the option to add a new piece down here instead of a plus icon here. If I add a piece, I can choose to add a title and some text. Colors work a little bit differently on iOS. So let me show you. This one is red, but the color was green on the piece. Notice that unlike Android, the text is now rendered as red, whereas Android rendered the background color of the navigation bar red. Likewise, if I navigate into more color, the text shows green, but the background color stayed the same. And there you go. That's our app. Now there's a lot of ways you could improve it, so we'll go over that next. So now that you've seen the app, I'm sure you have some ideas for improvement, and so did I. So here are some ideas that you might want to try your hand at. I think you'll feel really good when you complete each one. Now, our color picker is pretty lousy, and there's no error checking done if it's even a valid color. Why don't you create a new page that implements a better color picker? You could have a rainbow of colors on the page, or you could have a grid-like setup where each portion of the grid had a specific color. You could create different piece types. For example, you might want to create a to-do piece that would allow the user to check off items when completed and allow them to reorder the to-dos within the piece. Or you could create a URL piece where the URL points to a web page. If you recall, we used notes as the unique identifier for our collection of notes. You could extend everything out by a level and allow different kinds of collections of notes, kind of like folders. This would require an additional screen in front of the list of notes that you have presently. And it would be great to add search functionality. Framework 7 has search functionality almost built in. It wouldn't be hard to add, and it would greatly improve the usability of the app. So in this section we covered the wrap-up discussion, the demonstration of the app, and some ideas for improvement. At this point, this is the end of this course. Thanks for getting this far. And if you have any suggestions for other courses or improvements to this course, please let us know. Important links are at the bottom of your screen. The link to the code repository, and some helpful links to forums and Stack Overflow and the Slack channel if you get stuck with anything PhoneGap related. In this course, you've learned quite a lot. You've learned how to install Xcode and the Android SDKs. You've learned how to install all the dependencies that the PhoneGap CLI requires. And you've learned how to install the PhoneGap CLI. You've learned the differences between PhoneGap CLI and PhoneGap Build and the PhoneGap Developer app. You've learned how to configure a PhoneGap project and add iOS and Android platforms to it. You've also learned how to add plugins and edit the config.xml file. And you've created a usable productivity app that has lots of opportunities for expansion. So with all of that said, thanks, and I hope to see you again in another course.